Okay. Good afternoon. I am Rudy El-Khoury, Dean of the School of Architecture. Delighted to welcome you here today, to welcome you to our third annual Smart Cities Miami Conference, jointly hosted by the School of Architecture and the Center for Computational Science. The Center for Computational Science, we call it CCS, is a university-wide platform for research and services led by Dr. Nick Tinoremas. You will hear more from him this afternoon. And powered by advanced computation and digital technology. By the way, it is the home of our supercomputer, Pegasus. Focus areas at the center include climate and environmental hazards, computational biology and bioinformatics, data visualization, and, of course, smart cities, the area where the School of Architecture and CCS converge and collaborate on a number of exciting projects. These include, just to mention a few, the mapping of informal settlements with the use of drones and photogrammetry, actually a photogrammetry with a CCS twist, proprietary technology that is unrivaled in its economy and efficiency. We have various tests, experiments with ubiquitous sensors, including one in Miami Beach using new methods and technology for sensing and data analytics. Zen City is a smart city designed from the ground up in the Yucatan province. Some of its innovative features include customizable municipal amenities that the users can adjust using an online digital platform. We have automated public transportation system inspired by high-rise smart elevators, and a variety of public infrastructures for renewable energy. And we have the Zen City team here with us today, ready for the next phase in our partnership to take this project even further. These and other initiatives, including cutting-edge research on smart infrastructure at the College of Engineering, and projects in embedded technology at RAD, a lab at the School of Architecture dedicated to the Internet of Things. These projects position UM in the vanguard of the smart city field and compels us to sustain with the annual conference a public forum exploring the future of cities. So the conference isn't strictly an academic forum. Smart Cities Miami, as indicated by the title, is about smart cities, the smart city phenomenon in our city. The real world, in real world application and in partnerships with local government and industry. This is a forum for the larger community, entrepreneurs and innovators that are reinventing Miami as an incubator for tech startups, development and planning agencies in the public and private sectors that are guiding the evolution of one of the fastest growing cities in North America. We are interested in this public forum because we believe that we are at the threshold of significant transformations in the urban environment provoked by new services and practices driven by emerging technology. We are witnessing now the disruptive power of the likes of Uber, Airbnb, etc. But wait until the self-driving car is here, along with other radical disruptions that are sure to change the ways we imagine, inhabit, use, enjoy, manage, and govern our cities. I'm thinking in particular of the new platform for spatial computing introduced by Magic Leap, South Florida's most talked about tech startup. Rony Abovitz, Magic Leap's CEO, is here with us today to tell us more about it. But Before we move on to this much anticipated presentation, I would like to thank our participating sponsors, Build in Sumberg, IBM, the City of Coral Gables, and Zen City. Their generosity and vision have allowed the University of Miami School of Architecture and the Center for Computational Science to lead in this exciting and ever-evolving journey. And now, please welcome Provost Jeff Dirk, who has the honor of introducing our keynote speaker.
I too would like to welcome you here to the Smart Cities Conference, and I'm really honored to introduce our keynote speaker at this third annual Smart Cities Miami Conference. As we just heard, Rony Abovitz is the founder, president, and CEO of Magic Leap, based here in South Florida. And I think many of you have heard that Magic Leap is a technology company that has already raised billions of dollars in startup funds from companies like Google here in the United States and the Alibaba Group, and has partnerships with companies like AT&T and Home Depot and others, and media companies around the world. What you may not know is that Rony is born to Israeli immigrants and raised here in Broward County. And he was fascinated with computers and science at his youth. And as a young person, he wanted to be an artist, a scientist, a musician, an engineer. And I think you'll see that he has achieved all of those things. He has a BS in mechanical engineering and an MS in biomedical engineering from here at the University of Miami. And so we're pleased that he's not only one of our alumnus, but while he was here, he was not only a cartoonist and columnist for the Miami Hurricane, the campus newspaper, but he was a DJ for the radio station on the varsity track and field teams. So even in those days, he was a scientist, an artist, and an engineer. After leaving UM, he co-founded his first company, ZCAT Incorporated, a medical technology venture that revolutionized minimally invasive robotic surgery. And I think many of you may have already benefited from that technology as it exists today. I know I have, for example. Twice named a technology pioneer by the World Economic Forum, ZCAT spun off in 2004 to Mako Surgical Corp., which focused on haptic and touch robotic surgery for minimally invasive knee operations. I myself am going to have one on Monday. By the time Mako was sold in 2003 to Stryker Corporation, a medical device manufacturer, for $1.65 billion, the company had already grown to over 500 employees and more than $100 million in annual sales. And it was really one of the very first, if not the first, haptic robotic minimally invasive surgery devices. At Mako, Rony planted the original seeds for what we now know as Magic Leap, really in his spare time. In his spare time, he also created a graphic novel and feature film called The Hour Blue, and this alien planet was populated with talking robots, flying whales, and other imaginary creatures, some of which, if you've seen the Magic Leap technology, are part of the inspiration that the company uses to get all of us to think about technology and its applications in different ways. He sought the help of Weta Workshop, a New Zealand-based special effects shop best known for its work in The Lord of Rings, to really imagine not special effects, but really what computing should look and feel like. It shouldn't be a device, it should be an experience that we can all relate to, and really think about how we would bring computing to life. So it's my pleasure to introduce our alumnus, a pioneer here in South Florida, a venture capital, an inventor, Rony Abovitz.
I'd like to thank the Provost, Dean of Architecture, Dean of Engineering, and the President, and all of you for being here today. It's definitely a humbling thing. So my background, mechanical and biomedical engineering, so my only claim to architecture is that my uncle's an architect. What I'm going to talk about is a bit about what we do at Magic Leap Spatial Computing, which I think is a broad field that's going to cut through most aspects of life, and how we see that applying to cities and daily life, which I think could be relevant to this conference. A little bit about what we do at Magic Leap and what is spatial computing and how it's relevant to smart cities. So we're a spatial computing company. It took us a little bit of time to try to coin what we were and what we were not, and I'll define that a little better. And a core part of our mission is to harmonize people and technology together to unite and to make things better. And I think it's a really important part. We really want to focus on people, and I think anything to do with smart cities, when you look at technologies that could displace people, disrupt life, you have to think carefully about it. I think someone mentioned Uber and Airbnb and how those things are disruptive forces. Having some foresight, and one of the things we did was we partnered with the University of Miami on Project Alexandria, a campus-wide project, to think as a campus petri dish about these disruptive forces before you unleash them in the world en masse. And I think the campus is a great place to do that. You could sort of understand social disruptions, how to mitigate them, maybe a little better before you just unleash them in the world and then things just happen. We're all the recipients of lack of foresight sometimes. If you go back 100 years, everyone thought technology was just good. You just do good technology and good things happen. Not always true. So I think when you're designing smart cities, you want to keep that in mind about, is this going to help people? So our focus is always people in the center and surround them with technology. So part of what we do, and I think part of your thinking would be wonderful to incorporate into design, is that how do you amplify somebody? How do you amplify the world around them? How do you amplify your capabilities and intelligence? Which is, I think of that as like Tony Starking somebody. And you know, not the suit, you know, not the flying, maybe some of the flying at some point, but the idea that you've got this amplified intelligence which is binding the power of computing and data and AI around you, and imagine that citizens all over cities and things in cities will have sentience and awareness and intelligence. They're not just going to be static things anymore. They're going to almost be alive like nature is. Sort of the convergence that we're in today, I'm going to give you a little bit of our thoughts at where these things come from. So one side you have like telecommunications, you know, go back to like the late 1800s, Alexander Graham Bell, and you see the evolution of computing and communication like in parallel. You have like these things converge like in mobile computing in some way. You have both the ability to be mobile and you've got computing and you've got networks, so it's starting to come together. But what we think is a really interesting inflection point is the convergence of spatial computing and the emergence of like 5G. And what I mean by 5G is you can imagine like cities in particular, because it's very city oriented versus like suburb or like field oriented. You're going to have like edge computing, very low latency, massive amount of data with the ability to surge up and down data and computing. And it's going to be very city-like. So if you live outside these like new future cities, it's going to be like living in Kansas and then you go to Oz. And the convergence of spatial plus 5G and everything 5G and very low latency, super intense computing can provide is a whole new set of things that we're going to talk a little bit about today. So in our company, we break down, at least we think for the next 10, 15 years, what we see are 4 fundamental platforms. And the things, we see these fundamental platforms will tie into lots of things like IoT and other components. But these are the platforms we're working on that could be tools to be used in designing smart cities. The personal side is what we think of as sensory field computing. So to break down sensory field, we're in an academic place, it can be a little geeky. We think about light field physics, so the physics of light fields and how that interacts very specifically with your eye-brain system. So I come from a biomed background. How do you send a signal that respects how the eye-brain system works? Which means everything from like diopter mismatch being minimized to the frequency of light and adjusting the colors, warmer and cooler during different times of day, and human biorhythms, sound fields. So how do you have natural sound field? How do you have touch? So you can like touch digital objects. And really impedance match the human sensory input system is a good way to think of it. So you've got your whole brain is just a big sensory input system with processing and memory and all kinds of interesting things. But if you think of it as a big sensory computer, computers should become matched to that. And we think of that whole field as sensory field computing. And that's what we're doing with our first systems and beyond. So instead of you bending to a computer, computers should just fit how people are, how we are biologically in all ways. What we think of as a life stream is, I think, really important in smart city design. If you imagine 2 kinds of life stream, an analog and a digital, and I'll just go through it kind of quickly. If you could like capture every single thing you experienced, your experience path from the moment you're born through the moment you die, and everything externally as you move through life in that experience path. So it's like a space-time, almost like quantum physics path you're going through, but also your internal memory state. And if you could fully capture that, that would be like our mathematical definition of an analog life stream. The digital thing is what our sensors can capture. So we capture a portion of that, but the relevance of that could be incredibly important, like health biometrics, awareness, patterns of life. If you imagine a campus, like, you could see students moving and play that back. So we've done things where you can like walk around a space and then see yourself walking around that space later as a volumetric presence. And life streams is a term we use to think about this like massive, both internal emotional state plus external data state. And if you think about life streams on top of cities, it would tell you almost everything you need to know, whether they're captured by the personal devices or the sensors. It also brings incredibly important questions about privacy and security, and our view is that the life stream should be owned by the person who creates it. It's like your personal copyright. So you should fully own that, and you should have basically blockchain-type valves that open and close that allow you to share or not share. So you never give your data to anyone. You give them permission temporarily for a purpose, and then you kick them out. And until quantum computing comes up, I know somewhere at someone's working about that, there's probably blockchain and biometrics, which are multifactorial, that provide a lot of security on this. And then when quantum computing comes up, that's why we have Project Alexandria, because we have to figure out how do you stop that. So quantum computing will probably crack through all the different blocks you can put today. So it is something to think about. Like, you can operate probably with a good feeling of privacy with multifactorial, biometric, blockchain kind of things tied to your personal data. But then when you've got quantum, it's going to get interesting. Human-centered AI is a really important part, especially for us, where we want to bind the power of AI, which is this like force pushing through everything. I think it'll be a super relevant force in all future city designs, but amplify people with that. So a very simple way of thinking about human-centered AI, if I was playing chess with Garry Kasparov, but through my system, I could query Deep Blue and Watson and any other like AI system, and I'm just sitting there wearing what looks like this, and we're having a chess match on an analog chessboard, I will beat him all the time, because me plus the AI will always beat Garry Kasparov. So think about you as a person having access to a massive amount of intelligence and data, what that could mean. So in a city, imagine like the whole city of Miami had its own AI. We call that notion Oz. Like the city has its own AI, and it could tell you and everyone else what you need to know about Miami. And if you're a construction worker, it might tell you where you need to dig, because, oh, there's a pipe there, don't cut that. So the city itself should have an intelligence that could also help people within that city. And the last thing, we coined something called a Magic Verse, which is heart of the project we're doing with University of Miami, which is a total set. It's almost like the sum of the first three. So imagine a population of like 1 million people with sensory-field computing, with IoT in the city and infrastructure and drones and smart cars, like the total system. And how do you build that system, and how do you operate that system, and how does it all work together? So we're not building all of that. We're building components to plug into many other components. And some of those things are physical architecture. Some of those things are IoT companies and wiring systems and city planning. But the idea is, can you govern and operate things quite differently? So we'll spend most of the time talking about Magic Verse-like stuff here, because it's the sum of the first three. But one of the first things, it's like, think of it as a system of systems. So we're looking at city design as like total system engineering level and total simulation model level of all things that are happening. And how many of these like static and dynamic data points can you grab? And how do you model that? What kind of computing does it sit on? And could it be core and centralized and protected in some way, so that the people that have to govern the city and people who live in the city have some balanced way of interacting and taking care of all these services? So we see it as like, there's individual human life streams, but cities will generate life streams. You should be able to query the life stream of Miami at some point and understand its patterns of life across the total city, like at 2 a.m. on Saturday, what's going on, all over the place. And you also have to decide, I would say, in an open Western democratic society, what should you not gather? So I think that's a really important topic for smart city design in open Western democratic countries. What data should you not get? What data do you need to get? What's the line between security, knowing that someone's about to get mugged? You might be able to know that with a certain amount of data intelligence, but how far do you want to go before you turn into Minority Report? These are questions for a group like this, and questions to be answered in Project Alexandria. We also see many system layers. And one of the key things is if these layers don't talk, if they're not harmonized, you just have a bunch of disparate stuff. So part of our goal in proposing a notion like a magic verse is that you should have a harmonized city design and planning, not just the physical part, but all the digital parts, including a digital clone of the physical city. So the physical city we think of as a singleton. There is one physical Miami, and there should be one bona fide, legitimate, certified digital copy of the city of Miami to the highest degree of fidelity, or one high-fidelity digital model of the University of Miami. And then from that, you could springboard all these other layers, like the transportation layer, the energy and water layers, healthcare layers, education, communication infrastructures, entertainment. You could have almost an infinite amount of personalized layers. You could have, so each person can have their own view and access their own components, but there should be like certified, authentic, this is the current state of affairs digitally, because there's like one exact copy of that physical thing. So maintaining that's a really interesting problem. But if you have that physical singleton, it's the springboard for all these other digital services. One of the things we're working on proposing is like a kind of city-scale operating system to interlink the digital and physical, including creating like what is the AI of that city, digital singletons of people as they move through the city. So you might project an avatar. You might be in Paris, but project your avatar persona into the city of Miami. You might be walking around in a shop or having a meeting. Or you might project your avatar AI to go do something for you. And you might be projected in 10 cities at once. So the idea of having the digital replicants that have either direction or semi-autonomy becomes really interesting. And it's not stuff that's theoretical. It's actually stuff we're starting to do today. At CES a couple weeks ago, we had someone sitting at a table playing chess with a live digital presence avatar. It was very Kingsman, if you saw that movie, where they have the scene, they put on the glasses, everyone appears. It was pretty much that. So the notion of like a binding core OS for a city that ties all these disparate layers of services together, that ties to the architecture and the sensing, and I would say almost aliveness of stuff, like do buildings need to be sensed and alive? What's happening with the roads, the people and patterns of life? But does a rock sitting in an empty field, does it need to be sensed? The reality is once someone looks at it, it is sensed and captured, and then you could segment it and give it all kinds of metadata. That rock might be a waypoint for 2 students who leave secret notes there. And to you, it's a rock, but to them, it's an entire story, and digital flowers are growing out of it. So every object is potentially something that has relevance within a magic verse, beyond its known physicality. So we see this continuous cycle between what I'd say is the physical side, the persistent virtual and digital side, and like the simulation of different destinations. So there may be a Miami, and there may be portals in Miami that go beyond the physicality of Miami, which sounds, President Frank talked about the paradox of the power of place last fall, and the idea is that Miami has a really strong power of place, but you can give it portals so that you can look through that portal and see Berlin and Paris and maybe other countries, and those things could be embedded into the city of Miami. There could be a park that gives you portals to other parks around the world. There could be a park in Miami where if you walk in a similar park in London, you are now hanging out together. You are sitting on the same, there's a physical bench in Miami, you sit down, someone in London is sitting down, you see their physical digital twin and they see yours. So it's actually an interesting way of connecting other places and their power digitally, which adds a lot more amplification to what's possible within the physical domain of a city. A couple attributes of what we think of as spatial computing and magic verse, and I think they're different from normal computing attributes. And we've been testing it, it seems to be holding up. So I'll start with spatial computing. One of them is presence. The digital world, and this is something Dean Bardette and I were talking about earlier today, the digital world is hidden and unseen except when you pick up a phone or a laptop and you get little glimpses into it. Giving full presence to data all around you, to information experiences, it's like a Miyazaki movie where suddenly revealing the spirit world. So things could have scale, they're there, like we're all physically here, we're all present. I'm not a video screen. It's very different when you have real presence. There's something the human brain relates to true presence. And presence relates to how the visual cortex processes light field signals and sound field signals and touch. We take these inputs of sensory field to create a sense of presence neurologically. So Our computing and spatial computing is about recreating digitally the neurologic sense of presence and awareness. And that means you have to impedance match those signals into the brain to recreate that feeling that we all have right now. Scale is very important. Like, my phone is like 4 or 5 inch screen, but if I want to have a 40-foot building or a 300-foot building or a 50-story building or giant things, I can't really do that. I could have a wonderful CAD model trapped in my laptop, but if I want to go put that on a field and see what that's like full scale before I build it, I need real scale digitally. I have to take it out of that screen, put it out in the world. Awareness is really interesting, in particular for smart cities. You need sensing to understand what's happening and to be smart and aware. Our systems are aware of you and the environment simultaneously. And they will want to talk to objects that are aware of you and themselves simultaneously. So that's where this idea of like smart cities might become more like nature. If you're walking through the woods, everything is alive. The trees are somewhat aware of you, and animals are somewhat aware. So imagine physicality has awareness. And that's what software with spatial computing and also sensing really can do. And then you can add things like interactivity. Interactivity just doesn't mean a button. Like on our system, moving, breathing, your eye dilation, your heartbeat are all inputs into software. So really subtle, massively multi-input computing is relevant in spatial, and you have to think about what would the relevant IoT sensors be like. They could be much more subtle and sensitive than like just a switch on and off. And then how do you program things like that? Because it's not just, you know, multi-touch or I have a mouse and keyboard. You have these really interesting problems of like I/O when you have massive inputs. But that's much more like the real world. Respect is something that's non-technical, but we've inserted into spatial computing. Respect for design for human biology, respect for privacy, and respect for sociology. I think when you think at a city scale, you really have to think, how do you respect the governance and all the population in that city? You can imagine in some countries that are operated differently, non-democratic, you can have a huge disrespect for the population, and it becomes like a fascist central control nightmare. That's not what you want to do here. You want one where it's decentralized, you give as much power to the population, minimal central governance, you know, for core utilities and safety functions. So I think that architecture of respect and governance is super important, I'd say, for, you know, modern democratic countries, as opposed to the total misuse of this kind of technology that you might see in other countries one day. And it's a scary thing because it's got both really good and really bad potential. So hopefully at and here you can find the good parts and maybe try to suppress what could be negative from it. Really quickly, sentience, AI. Imagine your buildings, your cars, digital objects are not just simple, responsive things that are aware, have I/O, but are truly sentient. I mean, you could have like multi-hour conversations. They have professor-level IQ in a few years, and they might have in 10 years IQ beyond all human capabilities. So how do you involve sentience in a smart city? And when the city AI itself will be sentient, you know, what we call at Magic Leap and Oz, what does that mean? And how do you talk to the city of Miami one day when you have an AI that can know all things about Miami and what you need from it? So trying to make the argument that spatial computing is one of the major transformation functions on modern cities, and it's partially because there's infrastructure going to get built by giant telecommunication companies who are putting 5G in all the major cities in the United States and around the world. 19, 20, 21, 22, you're going to start to see this all over the modern world and in Asia. And then when you build on top of that, it sort of will become this like renaissance age for smart city. And then if you insert spatial computing and AI into that, you have this whole new toolbox that can completely change the thoughts on architecture and design, which is why this is exciting. If you're a student right now, it'd be super cool. Some pillars of livability, we've been involved in some like really crazy futuristic Epcot-like city design projects at Magic Leap. Just sort of give you a quick rundown. I think like you know, quality of the residential life is one factor to think about. What's your access to amenities? What are the amenities in that city? How do you connect with people? What's the quality of government interaction? Again, you know, how do you maintain an open, democratic, you know, non-centralized, non-fascist way of life? Really important thing to think about in the design of stuff like this. Safety functions, health safety, police, fire, And it's one of these things where you over-rotate and you make it super safe, but then you've lost all privacy and personal freedom. So you have to think about those balances. Quality of the environment, to be able to sense, like if you've got pollution, or maybe pollution you can't see, you can actually visualize that and say this part of the city has some toxic gas, avoid it, and everyone is routed somewhere else. What's the mobility? Drones, autonomous vehicles, how do you summon them? How do you have those things in a hybrid world not collide with people who are still riding bikes or driving their own cars? Education can be incredibly powerful. We're going to have a couple quick storyboards on that. Healthcare, super powerful. Imagine you're walking through Central Park, you have a spatial computing system on, and the system detects 5 minutes before you have a stroke that you're going to have a stroke. It picks up a small change in pulse, a little change in breathing, a little bit of eye dilation that have been machine-learned precursors to stroke, and it looks at your age and weight and everything else and says, oh, you're about to have a stroke. Summons a drone, summons a self-driving ambulance, and scans people around and goes, there's a doctor 50 yards away who's just having lunch with his kids. Summons that doctor, points an arrow right at the person, and you catch them before the stroke happened. Those are the interesting good things that could come if you converge all these different elements within like a future smart city, what we call a magic verse. How do you make quality of work better for people? So it's like not coal mining, but more creative, more intelligence-based work. What is the entertainment value, and what are the social norms in these kind of worlds? So I think there's a lot of real interesting pieces. And then like fundamental security. How do you make something safe? You could design a crime-free place because you're so super censored. As someone's approaching to mug you or rob you or break in, that's always known and all kinds of ways to prevent that. But is it an overly controlled world, and is it no longer something that you want to live on? So again, a great Project Alexandria question for students. How safe do you want to be on campus? Somebody wanders in from off the street, does the AI want to know that? So this is, I'm just going to show you a couple storyboards of how we are think about applying, and some projects where we are applying these things. So here's maybe some of you sitting on the 17th floor, and here's some future parts of, let's say, some Neo Miami getting constructed, and you're looking at the physical infrastructure not built yet. And this is the underlying, think of it as the mesh, but I would, almost like the matrix, but think of that mesh as not just static, but having dynamically updatable elements and elements that have metadata and sort of information quality that can change over time. So it's not just a static thing. Whoops. Go back one. So now you're looking at one building, and what's really interesting is go to that site and now see your design at scale. Walk into your design at scale. And just as an architect, that could be profoundly interesting, because a lot of people cannot really relate spatially what they're doing on screen to the site. Now, if you can, you're a master architect, you're probably the dean, you probably have that brain function. Most people don't. Most people have something here, and they're trying to correlate it to something in space and scale, and it makes no sense. You could do a lot of interesting tests with almost no cost, put your whole building. Imagine every architecture student could just design a 20-story building, put an empty lot, and you walk around your building. Or I designed a space like this, and I'm just in an empty field, fill it with people. I'm able to understand what all this looks like. I'm like, oh, move the podium over here. So you could do some of that in VR today, some of that in simulation, some of that in model building. But we think there's something powerful, like I'm at the site, I'm at the physical thing, I've got part of the rig there, and I've dropped this digital model, and it's full scale. And now what you're able to do is add other metadata components. It could be, I'm not just interested in the architecture, but what are the persistent digital parts of this building that are going to be there? Because as a digital physical architect or planner, it's no longer just the bricks, but you may design digital things that are extensions of that building that you don't have to build physically. And they may be there for 100 years, and that becomes really interesting. And now I'm looking at a different layer. This might be like an information or security layer across the entire city, and now you're going, that is just like designing a physical building, you have to put those things in space. So now you get to see across like the whole city of Miami all these different permanent digital structures that are living in space, tied geospatially to something. I may be looking at traffic patterns around new sites, and because I've got the pattern of life of what the highway was doing, I might be watching a real-time simulation on I-95 of that traffic next to my new building, and I might have like hundreds of people who are digital simulation AIs wandering around the real place, interacting with stuff. So there's something about being in that physical thing and doing it there, which adds like maybe that next step of accuracy and understanding what you're designing. And this might be looking at, let's say, the wind patterns, or what happens if a hurricane comes. So imagine you're designing a building and you have a hurricane sim from the environmental engineering department, and you see incoming waves, you see a Category 5, and you watch that wreck your new design city, and then you go, oh, let's change the aerodynamics in real time. So you're incorporating a lot of disparate functions, like something happens in a wind tunnel here and someone's computer over there, all at once, which means you need immense computing power. What's really cool, though, is immense computing power is actually coming really fast. When you think about a 5G city, you're going to have like edge computing, which could do a lot of like local buffer computing at super low latency, and then you'll query through fiber some supercomputing that you might have on campus or nearby. So you might be able to do some of these things in real time or near real time in the place. So a couple of quick use cases, really fast. This is an urban planning scenario. So in the sketches here, everything black and white is physical, and then all the colorful elements are digital. So what you have here is a bunch of people working, and then their colleagues have co-presenced in. They could be, let's say this is at and you've got a colleague from Berlin, from London, from Beirut, from anywhere in the world. And now they're designing that city we were wandering in, and you just sort of see tabletop, like you might have physical architectural models all just appear, and you're looking at all the layers. What's interesting here is you got physical people looking at a digital model they can change with colleagues who are digitally present from other parts of the world. And now in that same lab, you've blown the roof off and put like a third scale model of that. So you go, well, let me see what that's like in scale. So you're now easily expanded a model. This might take you, if you're an architecture student, 8 months to build. Digitally, it just took half a second to scale the thing up. And now you might have blown another part of the wall. What I mean by blown part of the wall is just erase its physical light field signal and impose your digital light field signal. And you're not looking at a flat monitor. You're looking at a spatial hole in the wall that shows you, like Miami, from your little lab. So you're looking at a volumetric, multi-view, full-scale portion of the city you're designing. So as you're tweaking the tabletop, the third scale model's changing, and also the view through the wall's changing. And you've got co-presence friends. Now you might be in the governance committee, and this is like sitting around looking at the whole city and its operations, and this might be your future command center, which is, I don't have a great metaphor, but it's like very Hunger Games-esque, I guess, without all the violence. But you can imagine, like, you need some place, which I think of as the command center, to see everything together. A lot of cities right now have this like giant NASA-like wall of monitors. One of the things we're proposing is that, it wouldn't be great to have like just a scale model of that city. You could scale up or down and just look at it and see everything happening in real time. And we've already built, first test simulations of this, which is really cool. Education, very relevant to being on campus. Very similar, you've got a bunch of students in a lab, again, co-presence. In a situation like this, half of you could be co-present from other universities in a talk like this. You've taken like the lecture hall and you've blown out portions of the windows and you're looking at some urban planning project. And what they're doing here is they're designing simulations of AIs and robots that are going to do some kind of farming activity. And then they see on the tabletop, this is the whole landscape they're working on together. But now they're out, they go off the city, they're in that urban farmland. And what's really interesting here is their co-presence fence can also appear. And full-scale versions of the things they were designing appear in the places that you'd want to build them in some kind of like, future farm agriculture design project. And including your AI, which is a little AI robot that has no mass, but it still functions with all the AI sentience and is aware of what's going on. And you have this physical robot digital model, which might become a physical robot one day. And now you're taking your simulations and putting them in place before you might do a dig. And then you might have like, drones passing, which could be for camera irrigation, and like you could have like farming equipment. So you're running your whole model of this like, agricultural urban planning thing you're doing without any real physical cost yet. It's almost all digital with a few physical people. And then running that test in the place gives you a real sense of what could happen. This one's actually kind of interesting because it's pretty much what we're doing right now. So if I had a friend, let's say I had a friend from Stanford or MIT, he might or she might just appear and be a co-lecturer, and other students might just appear. So if you had our, a spatial computing system on, and you look to the left and the right, there would be a room full of people just like you who are co-present. They might be sitting in another lecture hall like this, and you would be digital to them. What's really interesting is like how you can amplify a space by giving access to people who have like co-equal presence, but they just don't have atoms. And it means they could transport themselves really easily and quickly. And we are doing things like this right now, and it's actually quite amazing. I gave a talk in San Francisco. I was on stage with a friend of mine from Twilio. I was co-present as an avatar. I was in my office, but I was also on stage at the same time. It was a very weird, literally out-of-body kind of experience, but we're at the very beginning of that happening, and it's just like the first telephone calls. Like, now we don't think about it. So at some point, hopefully within the next decade, this will just be a no-brainer. Like every lecture at will be something like this. What's neat here is I could bring other elements outside of like PowerPoints into things like this, where I'm bringing full scale. Let's say we're talking about like DNA and botany. I'm like blowing out the back wall, and I'm showing the farmland, we're showing full-scale objects, and everyone suddenly has those objects sitting in front of them. So what professors will be able to do and lecturers will be able to do could be kind of interesting, because you could give personal access to a student to something, and then you can also do things at scale. A little quick thing on transportation. I know it's a topic. What do autonomous vehicles do, and how do they coexist? So here's something with autonomous vehicles and drones in some future city. And what you're seeing here is like for pedestrians, you might have continuously variable like signage that is a function of what's going on right now. So this means that enough spatial computing systems and enough IoT sensors are working together in sort of a grid kind of network to say, given what's happening right now, you can go, this car's going that way, this drone is here. So it's a dynamic situation. Like you think about stop signs today, they're very simplistic and static. In these future cities with all these autonomous things, the idea of having dynamically variable information and signage could be incredibly important to keep people safe. You might see the drone pathway. So for some reason, you might be the person in charge of like making sure the delivery drones don't crash into stuff. So you can understand, their highway and walk through the city. And if you're a planner, you might be able to change that highway by moving up or down, depending on different times of day, if you're building something. Here's a person going into an autonomous vehicle, and the digital people who appeared are members of her team, and they're going to have a conference inside that autonomous vehicle. So here she is being driven somewhere. Looks like they're playing D&D. I don't know what they're doing, but she's in the vehicle, but you got two co-presence friends in an autonomous vehicle, and they're having a meeting. So you think about, like, what am I going to do when something is driving me around? Am I creating a conference room? Am I having functional meetings? And in this case, we're proposing like that starts as she's walking into the device. So the vehicle knew that she had a meeting. The system knows where she is. She walks in, and her co-presence friends appear. Conference call scheduled. You got 20 minutes. So that became like something like a face-to-face physical meeting in an autonomous vehicle. This person is playing a Game of Thrones thing, which I won't comment on. This might be our friends in Seattle. I won't mention them by name, but this could be their package delivery system moving around. So I think there's a lot of interesting positive opportunity for transformation. There's some negative transformation that we should risk mitigate against. I kind of want to talk a little bit about benefits, and then we'll close. So what we think of as a magic-verse destination within a smart city on top of these like future 5G computing infrastructures, we think it affects like energy and water sector, transportation, planning, entertainment, education. We also think there's a big impact on manufacturing and manufacturing logistics. Food can get really interesting, like how do I get food? Sitting in a restaurant, what do I do while I'm waiting? Imagine a restaurant where the waiter was bad. You could tag that waiter with like 1 star. You could leave information for your friends, like this is the great pizza place, like the Big Cheese, this is how you get there. Imagine the live stream of like 30 years of students in like something like the Big Cheese, and if your big brother or big sister went there, you could see them when they were there 10 years ago. So it's a lot of really things to do with food and space and restaurants. Media will be really revolutionized. General tech, like how does tech come together? Something like this where You might be designing IoT, someone else creates a signal system, a radio system, traffic systems. They kind of need to all talk to each other. And we think profound impacts on like the citywide healthcare. Can you raise the entire bar for every citizen in a city? Really quickly, some propositions and a couple sectors, and then we'll close. So let's say for energy and water, you might have a need to make a resource visible. You might need to have visualization for the city operations, and you might need feedback by the people in the city to give to the people who govern the city what's going on. So you can have very actionable data visualization, not just see it passively, but action on it. You could have a lot of interesting remote monitoring. You could have interesting lighting systems that could provide cost savings across the whole city, because you could sense when lights are coming on and off in different ways and when people are there. So you only turn it on when there's these people there when they need it. For things like transportation, how do you have sustainable mobility? How do you visualize the traffic patterns of life throughout all kinds of day and events for city operations, and how do you optimize those things? And what's the interface for people who are coming and going from autonomous vehicles or semi-autonomous vehicles? So overall, you want to have much better efficiency. You don't want traffic jams, which probably means much better sensing and much better logistics and machine learning around how we manage patterning. How do we understand the impact of travel on the community? There are some communities in South Florida that someone just decided to put a highway in and destroyed some of those communities like 40, 50 years ago. How do we simulate that and then simulate the damage it might cause that whole community and say maybe that's not a good idea? And then how do you have better economic impact as you have less time stuck in traffic doing stuff? So all these are really interesting topics. I just wanted to seed you guys here. And then things like urban planning, so like the 3D modeling and simulations, things you really want to do well. How do you take all this different data, whether it's from traffic, weather, wind flow, AI simulations, IoT, to change policy of how the city is governed? Like saying all that and looking at our current government who can't pass a bill, sorry for saying that out loud, makes me wonder about the future we're trying to build in just daily basic functions. But we should plow through that and be very hopeful that we should be using technology to get to better decision making, so we don't have these kind of gridlocks. How do you make the best rational, optimal decision for a place, and how can technology help take politics out of it and make the best rational quality of life and economic benefit for all the citizens? And that's where you start to go, should AI be part of governance? And that's where these kind of questions will lead. Because you've got so much complexity, can 5 people or 100 people actually understand what's going on? Or do they need AI assistance and all these system level things to help them understand what they're doing? So it's really better engagement and awareness of proposals and construction projects and how they impact everything around them and how they fit into an overall master plan, and how do you promote things like healthier living and better working environments in an urban area. And then on healthcare, I came from medtech. I think the interfaces between doctors and patients and the amount of data that you can usefully collect about someone's life. Usually go to the doctor, they got 5 minutes. Okay, you have bad knee surgery. Okay, we got to pull this out of you. I mean, they spend 2-3 minutes on you, but you could gather years or months of incredibly important biometric data through spatial computing and smart city design that could then be fed to a healthcare AI that could really analyze what's really going on with you before, during, and after whatever intervention. And I think that's incredibly important because the doctors just don't have the time. So we need to use technology to normalize and make democratic access to the best possible healthcare. So it sounds, when you're an architect, are you worried about all these things? I would say yes, because cities can become much more intelligent, comprehensive, places where all these different services of human life come together. And then I'll kind of end on this. Sorry, one more slide. The economics of amplified cities, the economics of what we think of as magic verse, is that you're bringing places to people, so the opportunities are 10x, 100x, or 1000x amplified. Where if you're just physical, there's a finite set of opportunities. So if you're, like we were talking before, if you're an informal city, you've got very finite economic opportunities. If you were a magic-versed informal city, your economic opportunities increase substantially, maybe by hundreds or thousands of %. So the idea is the power of place gets amplified, and we see that very early on with the digital economy, just things like Amazon buying books. Think of an Amazon versus a physical bookstore. This is that on steroids for an entire city. So the extension of what they can propose externally with all the digital capabilities to other cities and people, and bringing other people in could greatly change the economy, where right now you have a finite economy by the amount of people who live here, can come and go by train or airplane or something like that. You have much faster, lower friction ways to bring things in and out with a digital sort of spatial economy. I just want to end and thank the University of Miami for letting us talk today. And just to highlight the current project we're working on is something we call Alexandria, which is to try to make Miami a hub, a hemispherical hub, for this kind of economic and technology development. So if you think about what this part of the world can do, from Latin America all the way up to Canada, and this part of the United States and outside the West Coast, there's some really interesting things we could do. And I think there's an opportunity for Miami and to sort of become leaders in this intersection between city design, AI, technology, sort of these 5G infrastructure. So anyway, thank you, everybody.
We don't have actually a lot of time, but I'm wondering if you could take a couple of questions.
Sure.
Just a couple of questions.
So very short answer to what really is a very long answer. But I would say is one, we're trying to turn into a petri dish for testing a bunch of these things. But I would say a small focal project with probably the most advanced tech-friendly team in Miami is the good first step. Something that is small in scope and has a short duration, like 12 months, where you can get a quick win. Because what I just described is 5 or 10 years of planning and design and implementation, but you need something that has a really high impact win that you could show people who are less tech savvy, maybe less futuristic. Simple application, first step. So if you guys are interested, the Alexandria project's a great place to partner and do something at and then clone it in Miami.
So would your city partners be people that are in the business? Are you looking for tech people? Are you looking for data people within cities?
Yes. Yeah, it's yes. Yeah, one more? We got two. I guess you were first by half a second.
So, Louis Cornell, CTO of an AI company. A little bit more going down a similar track with more technical details. How do you deal with the large I/O problem and the data storage and transport problem on something like blockchain?
So the large I/O problem, part of that is we're working really closely with some of the biggest telecommunication computing companies in the U.S. and outside the U.S. So part of the I/O with I would say where 5G is going, you're going to have variable massive data uploads. You can send terabytes of data super fast by saying I need to do this right now, and the whole system responds to you, and then you could punch that variable load. And I think that's super interesting, and we've been seeing background testing. It's very different from normal Wi-Fi and LTE. And then the mass amount of compute and storage, I think that's where players whether you're Google Compute or AWS are going to be putting different data centers in sort of these emerging cities. But it's also an opportunity for distributed grid kind of storage where there's SETI-like projects where the citizens might be able to store 20%, edge computing might be able to store 20%, and then cloud might do 60%. We're actually we're going pretty deep with that. We've got but I think the big three, Google Compute, AWS, and Microsoft with Azure, clearly have tons of capability to store data. But I think the 5G variable surge of data and compute is not fully known yet, probably outside of some R&D, but it's super exciting, where you could just punch immense data super fast within seconds, and that capability wasn't available for us. So I think it changes the thoughts around how you do a city. Cool. Thank you, guys.
We are going to proceed without a break now, but I promise you there's a very long break right after this first panel that's going to address smart city infrastructure, but more specifically in their potential relevance for Miami. And the moderator for this is Dr. Nicholas Tsinoremas, as I mentioned. He is the founding director of the Center for Computer Science. A university-wide platform for collaboration on computer-intensive project. Dr. Tsinoremas also holds the faculty positions at the College of Arts and Science and the Miller School of Medicine. His undergraduate degree is from University of Athens in Greece, and he has a PhD from the University of Leeds in the UK. I'm going to now invite our panelists and the moderator to come to the front for the first panel.
So thank you again for coming today. My name is Nick Tsinoremas. I know that Dean El-Khoury introduced me, so no more. I just wanted to say a couple of things to introduce our panel today. Today, actually, we have a very diverse and exciting panel that is talking about the smart cities and what we call it here about the infrastructure with a prospect of Miami. So as you've heard from Rony, smart cities can be a lot of things. Smart cities means how we are connected as citizens, how we are interacting with each other in a connected environment, and also how we actually are connected with the city decision makers and the governance of the city, and how we as citizens are actually interfacing and interacting, and we are actually going to a more direct governance, if you will. So if we look at a little bit about the smart city and have this in mind when our panelists are talking about, is that, we are talking about smart cities about connecting the citizens, connecting the decision makers, but also for all of this, it requires an infrastructure that all of these connections have to exist. Also, it requires for us to be responsible and understand of what it, as our keynote speaker was saying, is that what our limits and barriers. More connections means that we are losing certain things in privacy. Are we ready for that? What does it mean? So for certain things we may, for certain things not. So these are some of the questions and some of the discussion that we are going to have. So today, again, I'm not going to talk too much more. I would like we have a panelist that is a panel that is actually pretty broad, and it brings different perspectives. So be prepared about this. So what I'm going to ask now our panelists is to introduce themselves instead of me introducing them, and tell us a little bit about their role and where they come. So, and you will see that we have a mix from public sector and private sector, and how, hopefully we will all be discussing some of the issues. We can start with Ivan.
Do you want to go there?
So perhaps, yes, in order to expedite things, let's get one of the panelists coming here until we fix our microphone.
Hello. First of all, I would like to apologize for my poor English. My name is Ivan Espadas. I'm one of the co-founders of SenCity. SenCity is a private project. It's a smart city. We like to think it this city as a startup. We see all of the complex activities related to smart cities, so we thought that it could be a great idea to build an actually new smart city from the scratch. We are doing this in Mérida, Yucatán, Mexico, is very close to here. It's about 1 hour and a half flight. And we are working with the to design this city. So I'm very grateful for the Thank you, Dean, for inviting us. We are more than happy to share our experience. Thank you.
Can you try to speak loudly? I think the acoustics are good in this room. Try.
Yeah, perhaps we can try without.
Okay.
It seems that we have a more.
So, can you hear me? Yes. Okay, good. So, hi everybody. I am Eileen Higgins, and I am one of 13 county commissioners here in Miami-Dade County. And so my perspective on smart cities is very much based on what improves the quality of life for the people who live here. And so me, I'm very interested in having and hearing from the panelists today, because often when we talk about smart cities, we use things like IoT and ICT, and I have to talk to regular people, right? You all get to talk to city or county administration, right, who are experts, and you're talking, smart talk to smart people. But as elected officials, we have to explain how smart city technology and an investment in technology they may not understand improves their quality of life. And so the words that I get the privilege of using with the 2.7 million residents of our county have to be different, and have to be able to make sure that they fully understand how their lives will be better if their municipalities and their county invest in technology. So for me, that's a very, very important piece of the equation, is not using technical terms, but really making sure they understand the benefits and how their lives can very much improve. So.
Great. Thank you, Commissioner. My name is Darren Ware. I work for Cisco Systems, a technology company, and I focus on Latin America. I've been working with smart cities 8 or 10 years now. I have the pleasure of working with Zen City and many cities around primarily Latin America, but we also, of course, work with cities around the world. My first observation when I talk to cities is always there are 3 big basic areas where I think technology is in use in a city. The first is the back office, the basic municipal administration, the big building downtown. That's one. The next one is the relationship with the citizens, the citizen services, whether it's e-government or transactions or information that the city is responsible for delivering to the citizens. And the third one are the basic services, those services that take place in the street, transport, security, safety, smart lighting, smart parking, all of those things that happen with basic infrastructure. So the point of bringing those 3 together is, number one, there are technologies that can be different in each of the 3 buckets. And our point is often, how do we work to design the infrastructure properly so that you're not repeating things across the 3. You have horizontal infrastructure, which can even include transportation using fiber optics as the horizontal architecture that supports all of the solutions across a city. So, and again, as you're saying, the reason we do this is to help improve services satisfaction, to help improve operational efficiency, to improve citizen satisfaction and everything that goes into this. It's not about the technology. For us, certainly, it's about the impact that we can have in these smart and connected communities. So thank you for inviting me as well.
Thank you. Mike Salzman, Chief Development Officer at Brightline, soon to be Virgin Trains USA. And we have obviously invested a significant sum to date in the region, in the Tri-County area, really. And of course, have our Phase 2 project that most of you are probably aware of, from West Palm Beach to Orlando, that will be kicking off literally momentarily and hopefully open in about three years from now. But what's, I think, so interesting about the service that we have today, which for those of you who don't know or haven't ridden, and if you'd like to, please come see me after. I'm happy to get you on the train. But we've got service, of course, from West Palm Beach to Fort Lauderdale and on here to Miami Central Station in downtown Miami. And it's, we believe a wonderful laboratory for some of the smart cities concepts that a lot of folks on the panel were talking about from very different angles. Both from thinking about cities, not just in the traditional sense, but really the regionalization of the entire area. So our ability to connect Palm Beach County to Broward County to Miami-Dade County and residents in each of those places and really create different ways of living. I use myself as a good example, moved here from Manhattan, New York City, and had no particular affiliation with one part of the Tri-County area or another, but really chose to live up in Fort Lauderdale, about 5 minutes from the station, and commute in every day on the train. My family has one car with 2 little kids, wife, and in a house in Fort Lauderdale. It's sort of a whole notion that is almost unthinkable to a lot of folks in my neighborhood and to folks in the area as recently as just a few years ago. So that's just one anecdotal example. And then you think about here in Miami, we've built about 1.5 million square feet of transit-oriented development content. And again, if you think about the opportunity to create a truly connected, efficient, and frictionless city and place, we just think it's a wonderful sort of microcosm of the greater whole that can evolve. And then lastly, I'd say mobility is a key theme for our company. In Miami, we are at the confluence of Tri-Rail, Metro Mover, and of course the Bright Line. And it was no accident that we decided to really bring all those systems together in one place. We believe in a connected, transit-oriented city. And so it wasn't all about our own ridership. Of course, that's an important criteria. It was really about making sure people can get to where they need to go from our station and to start to create a transit-oriented mindset really here in this market in a way that didn't exist previously.
My name's Eric Singer. Great to be here. I'm an attorney at Bills and Sumberg here in Miami, and I focus on public-private partnerships. And I think just as smart city means a lot of different things to a lot of different people, I think public-private partnerships is a similar phrase with a lot of meanings. So the way, the space in which I work is working with local governments and private companies to work together to develop new public infrastructure, including technology infrastructure. And I work, depending on the situation, either for the government or for the private technology provider. And my experience has been mostly in South Florida, mostly in transportation infrastructure, including mass transit and mass transit technologies, smart parking solutions, and water and sewer infrastructure, which I think is sort of the, we don't think about it, it's sort of underground, and we hope it works. When it doesn't, then it's a problem for everybody. But there's a lot of innovation in that space going on right now in the technology world. So looking forward to talking about all of those.
Great. As you see, we have a very diverse panel. By the way, your microphone should be working now. Can you test them?
Test. Oh, yeah.
They're working. Okay, great. So I will still not use a microphone. So we have, as you see, a very diverse panel. And that's actually by design. So we can start talking for many different aspects, but hopefully we can try to put everything together. What was very interesting is that what we heard from Eileen is that, well, actually also part of the smart cities is that how do we communicate that concept to our citizens and also to the stakeholders and stockholders, if you will. That's something very interesting that we all have to keep in mind. Now, I would like to ask the panel a little bit to give us a little bit of a personal experience over the past couple of years, what they think it's an exciting smart city project that they were involved a little bit more in details, and why they think that this was something that is stuck in their minds. So with that, probably I will start with Darren. Okay. So we go that way.
Okay. So I'll go back to 1995 to 97. I lived in Buenos Aires, and at that time, if you've been to Buenos Aires recently, what you see today in both the metro and in the bus lane is that there is much more technology. There's much more connection between different forms of transportation. They've also started even to reduce the number of pedestrians in the center. So multiple changes happening on multiple layers across the different parts of the city, not only physical, but the transportation system has more technology. There's more Wi-Fi in the metro. There's more connection and information about the buses. There's also changes physically in the fact that there are now non-pedestrian zones. So all of these things pushing in the same direction of livability, right? It's making the center livable, giving the citizens information, using technology where is appropriate, and also using good old urban design where is also appropriate. So that's one that I think is over many, many years evolved a lot in a big city. Big cities are often trying very hard to do dozens of projects at the same time, right? And that sometimes is a challenge just because of the number of projects. But that's an example of one I think that has moved forward in those ways.
Eric, we'll go that way. We'll mix it up a little. So,
All right, does this work?
no, it's not working. It used to work, and now it's all
All right. So I'm going to go back to where I left off and talk about water and sewer a little bit, and hopefully I know it's not as sexy as Brightline now, Virgin Trains USA, but hopefully get you a little bit excited about what's coming in that space. So if any of you have been following what's going on with the water and sewer system here in Miami-Dade County, the system is riddled with leaks. It loses millions of gallons of water a year, which is a limited supply for us, particularly with the prospect of sea level rise. And the sewer system is completely falling apart, and we're under a consent decree from the Environmental Protection Agency to spend billions of dollars in very short order to get it fixed. And part of the issue is we have just very old, dumb technology where they check meters every couple months, and if you've had a leak that whole time, you wouldn't know about it until your water bill goes through the roof. And when you have a water leak, if it's in your home, you have more pressure on the sewer system as well, as that's where it ultimately goes. So what a number of governments are working on now is automated meter technology, where it's all wired in, where there's a smart meter at each house and throughout the system. So in real time, if there's a constant flow, it'll send you a warning, so you know that you have a leak, and maybe it's a faucet on, or maybe it's a leak somewhere in the pipes, either in your home or underground. And so that can, the leaks can be identified and fixed very, very quickly. Second, it allows the water utility to set pricing based on demand. So right now, water costs the same whenever you use it, even though most people use it sort of in the morning to shower, and at night when they run the dishwashers. It's not a constant flow, but they have to provide equipment that can meet these peaks. And by having sort of the second-to-second metering and feedback, they can adjust pricing based on demand and encourage people to sort of spread out their usage, maybe run the dishwasher midday instead of night when everyone else is running it, and reduce the amount of infrastructure required. So we can save water and be more efficient with this technology. Mike?
Well, it's not all sexy. I'll give you a couple examples, actually. So, look, I think we've just scratched the surface of the potential for these type of smart city applications as it relates to our service, how that interacts with the transit-oriented development, with the other commuter systems, and really with the entirety of the infrastructure that a lot of the folks on this panel helped build. So, I really think we're at like version 1.0 or maybe in beta, but there's a couple things that we've done. We've partnered with Lyft to create really an integrated approach such that someone can buy a ticket with us and a connection through with Lyft to the airport, for example. And the Lyft car will know when you're arriving, will be in the immediate vicinity, and you'll be picked up all included in your fare and taken to your destination, whether it be the airport, the cruise terminal, or elsewhere. So that's just one example. Another one being, we've worked with the boating community, actually. So for those of you who know Fort Lauderdale, you've got the New River and the New River Bridge, which has several vehicular bridges as well as our rail bridge. And we actually created an app for the boating community to help manage some of the frustration with the bridge being down a lot more than perhaps they had been used to, just to help them understand the timing and the cadence of the train traffic. So just another example of how trying to make the business community primarily, but also recreational owners' lives a little bit easier.
Well, I actually have seen some of the county and also some of our municipalities implement some pretty cool stuff that it's cool stuff to me, but it's smart city stuff to you guys. ShotSpotter, for those of you that are unfamiliar with that, has been a wildly successful tool that our police departments have implemented in neighborhoods that are afflicted by terrible gun violence. And one of the things you may not know about neighborhoods that are afflicted by gun violence is unless someone is injured or killed, the police never receive a 911 call about the shooting incident. And so now in many of our neighborhoods that are afflicted in this way, we have ShotSpotter technology that the police are actually, there's even an app for it. The police are notified that shots went out before 911 is even called. And so that has saved lives because ambulances are on their way and police are on their way. And so we know it has saved lives of victims because they're getting to our trauma center much more quickly than they would. And the police are collecting evidence a little more quickly than they would, and about shootings that they might never have heard of. And so the next phase of that, we haven't done a great job of convicting people with this yet. The next phase of that is actually to continue to have a more camera-related monitoring so we can get some visual evidence. So we often think of, sort of smarter, cooler technologies that move people around, but in this case, we're using amazing technology to save people's lives. So the other thing that I've seen, and I see Mike Strasty out there as part of the solution, is since I first, I'm a big transit user, and when I first moved to Miami, essentially, good luck to you, knowing when the train was going to come or when the trolley was going to come or when the bus was going to come. You just stood out there. And if it was hurricane season, it was raining. And if, you were just out there waiting around and maybe some sort of form of transit would come by. And so we have done a pretty good job at creating app-based technology that I can now, before I walk outside, know, when is the S bus going to be coming. So that has been outrageously helpful to people in using transit. This is a county of, I think it's 34 municipalities plus a county, so we still don't have one integrated app. So we certainly have counties that are running, cities that are running little municipal trolleys and other services we don't have one place for that yet, so that's sort of a next step for there. And so for me, it's awesome. I pull out my phone and I know what to do. But I'm not an 80-year-old abuelita living in Vista Alegre apartments, okay? So for her, smart technology would not be an app that tells her when the bus is. It would be actually an LED sign on the bus stop. So one of the things we have to remember is as we sit around and talk tech and are comfortable with tech, we have a population in this county, some of whom are older, some of whom don't speak English, and we need to make sure that smart cities work for them. And so a smart cities app-based solution for me is not necessarily helpful to our senior citizens. Another thing that, it's interesting, Mike actually fed me this thought about homelessness and identification, because I've been very worried at the county. We have a program where if you're homeless, you can get free public transportation with a card. But if you're homeless, you often lose your card for a couple of reasons. Sometimes they have mental health issues, but other times their things are stolen, and so they end up with no identification. And so, I began to think, like, just why does identification have to be a card for our homeless population? Why isn't it a cloud-based system that is based on whether it's fingerprints or eyes or things like that? So there are all kinds of ways, and thank you for bringing up, I think we talked about relieving congestion. We, in this county, I don't even know if we're at phase 1 yet. We have deployed, I think it's 300 smart traffic signals, so we're beginning to try to move traffic based on what's actually happening on the street versus what's happening in some traffic engineer's mind, but we don't have nearly enough for that. And so, we have people, and including me, our residents, they ask, like, why am I in a bus, and why is my bus stopped at the traffic light? Right? If you're, why when I am on the S or the 120 going from downtown Miami to Miami Beach in an articulated bus filled with, could be 120 people, why are those 120 people stopped at a red light so that 3 cars can come out of Star Island, right? We could adjust that traffic signal so those folks could wait an extra 30 seconds for the extra to go. And so there's so much more that we are experimenting with, but we need both money and new technology for. So those are some of the things that, this makes me insane. We, all over the city of Miami, and we'll have a street light, red, yellow, green, you know what I'm talking about? And the light bulb was burned out. And I have to report it. Like, why don't we know when our light bulbs are burned out? So I have been to other cities that know when their light bulbs are burned out. So I know it's possible.
We can do it.
We can do it, you guys. So we're making tons of progress, but we have a long way to go. And the way we are going to go is going to be really, really exciting and transformational.
Evan?
Well, this question
I'm
was
sure you
about...
have a lot of things to
Yes.
say about that.
This question was about how I got into the smart cities field. So I'm going to tell you a short version of the story. I think it's interesting. And I'm going to try to link it to why I'm here. Why can we use some of the things that we are going to test in Sin City for Miami County. I own a software company, and we are growing very fast in Mexico. So we went from 10 people, from 20 people, from 50 to actually 200 people. And we need to grow about 1,000 people in the next year. So it's crazy. So I talked to the government in Mexico. They are doing a lot of things about the public policies to start to put the Yucatan as a technology pole. We have the Mayan culture who invented the zero. So we are kind of a race who has something to say in software for the world. So the government put a scientific park and a free economic zone for IT companies. So we saw an opportunity for my company and for why don't we create a smart city here? Because every scientific park and every free economic zone who is successful in the world needs a community there. So we thought, would it be great to start a new city here? So we went to talk to a lot of people, and there are a lot of people who believe in this model. So we are now about 18 people. Some of our partners are here. We are the co-founders of this project. So we like to see it like the prototype city of the future. We love to hear, we are technology-involved people who love technology. But we see the smart cities fields like very complex things to arrange in existing cities. You need to evangelize to the city mayor about the benefits, about the quality of life, about the purpose of doing that. So if that is hard in the United States, imagine how hard is that in Mexico. So we thought, okay, those things are great, but we can't just wait until the government does something. So let's us do something. So we are creating this. We have been lucky enough to know people like Rudy, like Nick, and like Alejandra, who introduced ourselves to this university. We talked to them about the sensitive project. Rudy, I always tell this story because the second I ended, he was like, "I'm in." So we are very happy of doing this, and we are putting the sensitive project like a living lab for like a showroom of what a city should be. Because you have the energy technologies and the water technologies and the public transport technologies, and those already exist. But it's difficult to arrange that in an integrated project, in an integrated platform. All of the companies in the world are trying to put a platform. So we thought it could be a great idea to put this living lab, to invite UM to see Sensity as their living lab for smart cities, to collaborate with other companies to actually doing that. So we think if we could test those infrastructure integrated, that could be a good way to start to put in those things here in Miami. So that's pretty much why I'm here and why I got into the smart cities field. Thank you.
Great, thank you, Ivan, because I think that, well, the next question that I will have for our panelists is a little bit, where Ivan left it, which is basically here we're in the Miami, South Florida, broader metro Miami area. And I will ask actually a little bit from their own experience, our panelists, what they would think that this is actually one project that is, I would say, immediately applicable as a smart city, and another one that is perhaps a little bit more visionary type of projects that they will see that have to be adapted for this area, because we are a unique area as well, right? So we have a lot of coastal areas, have Everglades and so forth. So I would ask them to, from their experiences, if they want to pick, one more pragmatical and one more visionary type of project, where that would be. I will start with Commissioner.
Okay.
Yes, Higgins.
Well, okay, one is going to be super practical. We have got to do everything possible in the short term to figure out what we can do technology-wise to improve traffic congestion. And everybody who lives here knows that we have all these longer-term plans for more complicated versions of public transportation, trains, but they're big build, long time frame, big dollar projects. But what do we do between now and 10 years from now, right? And so we know that we can deploy more technology that moves cars more efficiently, but also in doing that makes clear how we get pedestrians across the street, since Florida was just voted #1 in the worst way in pedestrian deaths yesterday. So I think traffic congestion and how we move around our streets has to be a very practical priority. And then maybe this isn't long term, but one of my wish list is, obviously we're extremely vulnerable to sea level rise, and if we we need to use every tool that we have, and probably tools that haven't yet been invented, to make sure we are prepared and ready for that. And so everything from flood monitoring, the city of Miami rolled out a whole new way of looking at our king tides, which is using drone technology. And so I just think that's the other area that from a, what can we do for quality of life now, and what can we do to make sure we always have quality of life, is resiliency related.
You have my vote. I think long term.
Go ahead, tell us a little bit. I mean, if you want to elaborate, if you are involved in some of the projects, that could be also clear.
Right.
By
Well,
all
I
means.
think in terms of short-term ideas, transportation-wise, there's so many things still left to do or to think about that are non-technology also.
Right.
Simply
Bus lanes.
I mean, they're very well-known, the license plate numbers. So, Thursday, you can't drive. You can't drive. We don't say those 3 words, right, in this city. So that's a very, very simple one. Not that I'm going to stop driving myself, but
I'll have
that's
to
the
make
problem,
a citizen's
right?
arrest.
That's the the long-term one, the long-term vision, what could happen is to think about if, like Mr. Magic Leap said earlier, if we have the sensors everywhere, if we have all of those things, if we have citizen sensors on all the houses, the stoplights, the roads, the cars, everything, then we're going to have, obviously, petabytes of new data with which we can explore relationships, explore how the king tides affect school population, which is connected to the traffic, which is connected to ridership, which is connected to how do we reprogram the streetlights. We haven't had the opportunity to connect all of those data sets yet, right? This is a CCS, right? There's a supercomputer. Those things haven't been explored, right? And once we get to do that at the level of overtime and then eventually in real time, we're going to learn new things about how the traffic patterns work and how we can improve them. The 3 cars waiting on Star Island for the bus to go by. We'll know when these things happen. It's all about operational efficiency, using urban-wide data that has to be captured, has to be analyzed and used to figure out what can we improve, right? So that's not quite here yet. We'll need Magic Leap for that for sure, but it's a good one.
Yeah, I guess I'd echo what both the other panelists mentioned around congestion. It's a horrible problem in this region. Just to give you 2 interesting statistics that will probably weigh pretty heavily on a lot of you who travel this corridor. But I think the average speed today on 95 in Miami-Dade County is 33 miles per hour, if you can believe that. And this stretch of highway in Miami-Dade was just named the most dangerous in the entire eastern seaboard. So you can just imagine 95, which runs through a bunch of major cities all along the coast, is the most dangerous. So you've got a congestion issue, you've got a safety issue, and we've got to look at ways of getting people off the road. So obviously, a big part of what we've endeavored to do is to understand, is to try to deploy, infrastructure that will enable that. So I think our system, statewide, we think will take about 4 million cars off the road, once it reaches stabilization. So that's helpful. But I'd say the question was, what can we do in the near term? And I'd say it really relies on, understanding, really research and incentives. And so, I think about what our marketing department's actually doing today, which is thinking about, well, who's riding our train and who's not riding our train? And if you're not riding our train, why aren't you riding our train? And, so we've, launched some internal initiatives and research to really understand the mindset of the commuter. And I think there's probably an opportunity for a lot of folks, from the public sector and the private sector to work together on that type of research? Because really, at the end of the day, there are lots of reasons. Probably the biggest one is just the whole notion of friction, right? It feels like it's harder for me to go travel to the train station, take the train, get off the train, and go to my final destination. So how do we all work together based on what we learn from that research to reduce that friction at each of those stages along the way? Obviously, part of the solution is increased mobility in transit, but I think maybe to go to the second part of the question, which what's the long-term vision, it seems to me that having even further incentives and public sector and private sector support around transit-oriented development, is a big part of the solution, because the reality is if you live 20 miles west of our station in Broward County, you're probably not driving in and taking the train. So how do we encourage citizens to move closer to transit? And how do we encourage the development community and the public sector to create places that are walkable and livable in that sort of way?
So I think I've already tipped my hand as to what I'd like to see in the short term, which is the automated metering infrastructure for water. Sort of longer term or bigger picture, I'm going to return to something Commissioner Higgins mentioned previously about both shot spotter, lights that tell you when they're burnt out, and public safety monitoring. And it's technology-wise, that's here, and there are governments in the process of implementing that sort of as a single solution. Is that certainly in Miami-Dade County, where you have a regional government that controls this supply of streetlights, you already have this infrastructure in place that you can use to mount all sorts of technology. You don't have to go buy the rights from private landowners, and so sort of using the streetlights as a mount for smart city infrastructure is it's here, it's possible, but sort of taking the next step and from ShotSpotter and notifying the authorities when a light is burnt out, to really maximizing the potential of what's effectively a regional monitoring system. So you can have cameras that send out a signal when the trash cans are full, or when buses are late, or when there's a pothole in the road. So there's a lot of potential to sort of use that monitoring to make the whole public infrastructure much more efficient and much more user-friendly. I think as a lawyer, kind of the concern on the other side as well, when you're talking about a regional monitoring system, well, what's the government monitoring, and what are they using with all that data? There's cameras and microphones wherever you go in public. I think that's a potential privacy concern. It's a potential political concern. I think red light cameras make a whole lot of sense to me in terms of you don't need police to monitor that. It improves public safety, and yet, as we've seen that play out, the public hates it. And a lot of them have been put up and then taken back down. So sort of the aspirational part of that is not a technology shortfall. It's sort of a political buy-in shortfall, and a need to really figure out how to draw the line for privacy purposes, of what's allowed and what's not allowed, and what are you going to do with the data, and who is that being audited and monitored by a third party, to actually get to a point where we can implement that sort of solution.
Great. And actually, Ivan, I would rephrase the question for you, because Ivan is the only one who is not actually living in the Miami broader area, although he visits often. So what would you say that you've learned from the Zen City project, starting a smart city from the ground up, and what sort of experiences you want to share, and what advice you can give to an already existing city has got different type of problems and legacies that perhaps you didn't have to. So what would you say to a city like Miami, how to approach the thing?
I think you should concentrate in quick wins, like the guy from Magic Leap said, because sometimes when you have a quick win, it's easier to do the next things. So one sub-project that we have in Sen City that I think is a good idea to share here is that we see the world like a hybrid place. It's not an online place, it's not a physical place, it's a hybrid. So we are exploring this platform, this software platform, which is like a Facebook, but for you to interact with the city. So it's like for each citizen, a different city. So it's a customized city. So you already have a lot of software programs, a lot of data. So maybe not for all the experience, but you can integrate all the points of interactions that you already have for the citizen in one single place. So I think that could be, I don't know really if you already have that, but maybe that could be a good starting point. That's a quick win, and it's not too easy to do it, but it's easier than other things to integrate every point of interaction in one single place.
Great, thanks. Actually, this is a great thing, and actually this is also relating to my next question before I open it to the audience for their questions. And actually it's something that Eric started touching, which is about, now that we are talking about smart cities, we are bringing in a lot of, how can I say, new technologies, but not technologies, but ways that we share information about ourselves, about our city, about our neighbors, and who has access to this information. Right? I don't want to bring in stories like Facebook and so forth, that we all realize that, oh, third parties and fourth parties have got access to our private information. So if we think a little bit about all of this, I think, and Eric brought this, I would like a little bit of our panel, to talk about what are these new challenges that we have, that we as citizens, but also as governmental entities, we need to be aware. What are the new ethical, what are the new regulations, laws that we all need to think? Do we have them in place? What it's missing, and how we can bridge this gap. And I will start actually with Eric, because he is the one who's actually, at the end of his comments last time, he actually brought some of these questions.
So when any of these solutions to provide a public infrastructure or public technology is implemented, at the end of the day, there's a contract. And when it goes to approval, if you were to get a full copy of the agenda, there's often hundreds of pages at the end, and nobody goes through and reads those, at least from the public. I'm sure Commissioner Higgins does.
Oh, I do.
But it's very hard to draft a contract for a technology-based product or infrastructure that sort of contemplates future change and what issues are going to come up. And that's sort of the fundamental problem. And I think technology changes. I think that's an obvious point. We all get that, and yet our contracts never really contemplate that. And just as one kind of infamous example, the Chicago parking meter deal, which is one of the most maligned public-private partnerships around, where there was a hot new technology of, some of you I think they exist somewhere, but still, where you have these, instead of putting coins in the meter, you go to this machine and you punch in your license plate number and you pay with credit card. That seems like 20 years ago. It was probably 3 years ago that was the new technology. But Chicago sold the rights to all of the parking in the city to a company that would provide that technology. What happens? Then a few years later, pay by phone is the new technology. Now, of course, everyone uses an app to pay for their parking. But the contract didn't contemplate that at all. And they ended up having to renegotiate the whole contract at a huge cost to the city in order to get the operator to provide the new technology. So, and there's a lot of examples of this sort of fundamental problem. I mean, going back hundreds of years. So in Boston, to cross the river from Boston to Cambridge, there was a contract that was supposed to go on forever with a ferry operator. And then 20 years later, the hot new technology of bridge came along, and it went all the way up to the Supreme Court twice to get through that. So I think the important thing is to try to be very thoughtful, try about it up front, but also make sure that the elected officials, the policymakers, ultimately have control. And I think the one way to do that is to give the government a right always to terminate the contract for convenience. When technology changes or some new privacy or ethical issue pops up that we wouldn't have foreseen. And there's going to be a price associated with that. I think there has to be if the contractor's invested money with, based on an assumed return or period of time. But just because we really can't anticipate what's going to come in the future, we just know it's going to come. That's one mechanism to try to deal with that.
Actually, I will go to Commissioner Higgins actually and say, because you made some actually interesting comments here at the beginning also says that, well, somehow we have to explain and have to communicate with our citizens what smart city is. But how you think that now we can tell them that some of these things that are coming down, certain aspects of what we thought about privacy, they may be changing, and how engaged the citizens could be and should be in order to determine the new ways of dealing with this, because certain things may be acceptable and certain things may not be acceptable.
Well, I mean, it's interesting because in the past, who knows, it's been 2 years, but all of the both data breaches from some of the biggest companies in the US and of course, Facebook fundamentally telling basically anyone everything about us with or without our permission. I think it's interesting. I would say 5 years ago, you worried about privacy. It was a different age group of people, right, that weren't sort of digital natives or people that were very comfortable with that. But because the digital world has actually let down digital natives on privacy, I don't even think we're starting at zero here on that. I think we're starting, backwards. And so how we address that is simply trying to, we're going to be dependent on all of them to not do this anymore. Well, I hope not anyway. So it's literally collectively what's happened, I believe, is a societal issue is, for lack of a better phrase, I'm going to lump them all together into Silicon Valley. But they let us down, and they took our information and they gave it to people, and they weren't clear that they were doing it. And so I do think people of all ages and all digital skills now are somewhat skeptical when we say we're protecting your privacy. So it is harder to do that. And I'll go back to Eric's example about red light cameras. I mean, it's fascinating. If we can implement technology in a way that improves my quality of life, maybe I'll be willing to give up a little privacy. In this case, red light cameras are super convenient for cities. It allows them to raise revenue without having any human beings involved, and so the privacy issues is making my life worse as a driver, even though I'm speaking for a friend now, I shouldn't be driving through a red light. But when that's what we're doing, it's self-serving as governments, right? We're making government efficient so we can raise more money more easily off the backs of our residents, right? Versus we're using technology that every one of our technology projects improves their quality of life. And so maybe slowly but surely we can earn their trust back. But that onus is not just on municipal governments and state governments and the federal government. That onus is on everybody working in technology to stop letting the people down on privacy.
Yeah, agreed, absolutely. The other part of that very dramatic last year, Atlanta being cyber attacked and basically hijacked.
Yeah.
Our threat intelligence arm at Cisco says there are 20 billion attacks per day, right, all across the world. So 3 attacks per every 7 people, or 7 million people, all the time. I talked to a city here in Florida last year. They told me at their level they were receiving 40,000 attacks per day, right? So this is absolutely no longer just a kid in a hoodie, right? This is an army of people with a supercomputer sending automated attacks by the thousands, right, to a city like Atlanta and shut them down for days. So the bad news is on that side is that's organized, it's happening, it's scary. We're, as an industry, obviously very aware of that and trying to do as much as we can. That's not going away, but it's certainly something we're working hard to get in front of.
Yeah, I'll answer this question fairly briefly. It's certainly not my area of expertise, but I'll tell you we do gather a lot of data on our customers and understanding travel patterns, and I really think from an ethical standpoint, it's incumbent upon our company and every other company that is using really strategic data-driven marketing, which is soon to be just about anyone, to be very thoughtful about where you draw the line between creating customized, tailored offers and creating situations that, by any reasonable person standard, would be an invasion of privacy. So, that's really it.
Even if you would share some of your thoughts, because you may have a unique perspective.
Sure.
When it's a city starting as a smart city,
Sure.
how would you, what are your thoughts about this?
We are seeing all over the world efforts of innovation, like today, early, this competition, these hackathons. Everybody wants to innovate. So to do that, you need freedom, and you need open data platforms, and you need the willingness, I don't know if that's correct in English, from the government to do that. But it's not just freedom, because all of the things that we already said. So I think we need a framework of rules that are needed, but within that framework, we need freedom. So it's a big challenge, but it's a mix that have to be set in order to get the innovations from a living lab perspective, because there's no better innovation than the one who arises from the problem, from the people who are suffering the things or the problems. So those people are the perfect guys who could find a new solution for resolve some problem. So the people need freedom, but need a but the government, I think, needs to put a framework with rules to get everybody happy,
Great. So we have now some time to actually take your questions. Hopefully we can continue some of these topics. Are there any questions from the audience? Do you have any questions for any of the topics?
So, I'm glad that you mentioned that you feel that we need kind of a baseline technological foundation, right, of gathering certain kinds of data. Juxtaposed with the kind of data that you would get from cameras, right? Clearly, you wouldn't want camera information to be just public and stored and available. So,
So I guess, but let me rephrase the question for you, is that as we talk about the different regulations and different things and the innovation, do we really need to have, let's say, high definition cameras everywhere so we can measure, or, you know, with the accuracy that we want, or perhaps we can innovate and find new ways where the privacy of trying to have everybody, you know, with their full characteristics, and we have all of this data. So how do you think that this is playing? So is this the innovation of new technologies that they basically, you know, take into consideration some of these privacy issues in addition to the regulations? So.
In Sin City, we are planning to every citizen who lives in Sin City who should have the willingness to share their data, but not their privacy data. So I could share my data use, and companies like Cisco could use that information to improve their products and services, but not the privacy. So it's a tiny line, but I think it could work.
I'm no expert on that,
I-
so
on the-
I'll pass.
One thing I think has happened is, I mean, in Europe with the GDPR, with the regulations there, so in that case is what's happening, actually the legal framework has innovated in front of the technology, right? We can pull out the metadata from, you know, erase everybody's MAC address, just put, you know, total metadata to be able to analyze patterns and things like that. But those things are going to happen when the companies are forced to do that, right? Technology is going to go more quickly to get as much detail as possible because that's where the richness is in the data. Not that that's right or wrong, but that's what the law has allowed in some places until now. Now in Europe, it's very restricted in terms of what you're going to be able to do with that level of data. I don't know, you have thoughts on the legal part of that, but there's still more to happen, for sure.
Yeah, I think it's an interesting thought. I mean, I think there's a lot of places you could draw the line. It seems, though, that there's an inherent trade-off when you're going from sort of high-definition video to just blob people. Maybe there's certain things you can see, and of course there's certain things you can't. I don't know if what resolution you need to see if the trash cans are full, probably less than seeing someone's facial features. But from a public safety perspective, if someone commits a murder in front of a camera, you know, giving up identifying the culprit is a cost. And I think if you can turn it on and off, then you get into the trust issue of, you know, well, are they really only turning it on when there's a murder, or so, you know, when you go in through the airport and those body scanners, and there's a little picture showing what the operator can see that's supposed to make you comfortable. I don't know if I trust that or not. I don't know what they can see when I go through that body scanner. But I think there is that line drawing problem and a trust problem. So it's a good idea. I just don't know where the right place is.
We have, a couple of questions.
In Zen City, who are you targeting for the people that live there? Is it going to be the younger generation, the people that already are living in that area, or is it someone, is it new generation?
Are you talking about who is going to live in Sin City?
Who's going to occupy that area and that technology?
Okay. We had a first theory that is based in some things. We are the most secure state in Mexico. A lot of countries want to be in Mexico because it's close to the US and it's cheaper, the cost of labor and other things. But they don't come or they don't go because they think it's unsecure. So we live in a place who has levels of security like Switzerland, but nobody knows that. So we are kind of telling that story. So we thought could be a good idea for IT companies who establish there. There are some near-shore advantages there and other things. But then we brought the vision about that, because we think every company who wants to be part, who don't want to be the next Kodak or the next Blockbuster, they want their collaborators to work in a place where it's different rules of engagement and different rules of governance, or different rules of everything. We think they would be willing to live there. But we think first we need the economic reason, and then to put the houses and the services and other things. But there is a business plan going now, because we need to resolve that. Yes.
We have one more question. Time for one more question. Okay. Well,
Eric, with P3s, has there been any reluctancy on either side, private or public, on moving forward to implement the technology? What has been the typical, I guess, barrier to overcome?
So I think there's two phases there. So one is sort of, I mentioned before, sort of once you have a contract to do X, what do you do about improving upon that technology? So going from the pay meters with the credit cards to the pay by phone. So yes, if the contract doesn't provide a financial incentive for the contractor to innovate, there won't be innovation. And I've definitely seen that. That's a common problem. And there are some mechanisms to try to create those incentives as technology improves, but because it's hard to envision, I mean, it always looks obvious in retrospect, but I don't know what the next parking innovation would be if we were to enter into a pay-by-app contract now. I don't know how silly that would look in 10 years, or how we could plan for that. But sort of the earlier phase, sort of the initial innovation. I mean, the technologies are there. There's a lot of startups that have great ideas, but getting them to invest in a process with the government to enter into a P3 is a little more challenging, and I think it takes a lot of commitment from the elected officials that they're going to stay the course, that they're not going to put a full technology proposal together on, say, an infrastructure P3. It's in the 7 figures. It's a lot of commitment on the private sector, and they're putting trust that it's actually going to happen. And so that's sort of where the elected officials can come in, and the administration as well, just to kind of try to make the private sector comfortable that it's going to be a fair process and that they're going to stay the course.
Thank you. With that, I think that we are going to close this panel. I would like to thank our panelists today. We had a great discussion. And we will continue in 10 minutes. We're going to take a 10-minute break with the next panel. So we should be here by 3:25.
Okay, we are about to start the next panel. I'm going to introduce the moderator. Joel Lemire is an assistant professor at the University of Miami School of Architecture. Before joining us this fall here, he was formerly the former Homer A. Burnell Chair at MIT, where he had been teaching courses in architectural geometry, design, and representation since 2007. His research addresses the future of building practice through innovation in emerging means and methods, including digital fabrication techniques and evolving simulative design environments. Joel established the design practice GLD with partner Cynthia Gunadi in 2010 to pursue the middle ground between full-scale buildings and pure research.
All right, thank you, Rudy. Welcome to the second of the moderated panels for the afternoon. I think it's worth mentioning, first of all, that I'm going to try to recede into the background as quickly as possible here and let our many guests do most of the speaking. Just a couple of small points that I'll make first. This second panel is much more about questions of the design and construction of smart cities rather than the smart cities and their infrastructure as artifacts. And so we're moving away from, let's say, from projects to process, right? So, you know, in addition to, if everyone has these concerns about questions of how changing technology makes cities smarter, this group is a little bit also concerned with the question of how these emerging technologies makes the design and construction of smarter cities smarter, right? So that's change in focus between the infrastructure or project and the process. Also then mandates a slight change in format. So this panel will have a slightly different format than the previous one, starting with the inclusion of slides. So I'll actually put it out there to my panelists relatively quickly here, and then they will start to show a few of their own images. I want to also open it up to audience questions as quickly as possible, so I'm going to act as a kind of a brief moderator, but please intervene as audience members as quickly as you can. So I will just at least run through the names very quickly here. So we have Lorenzo Valdez from Turner Construction, Steve Oxtick-Kolnis, who's written several books on AR and VR, in particular this latest, Practical AR, Amy DiDonato, who is an interaction designer at Magic Leap, working down the line, Olivia Ramos, founder and CEO of Deep Blocks, and Christian Robio, founder of Clarity Value Inc., among other sort of entrepreneurial startups. So I'm going to hand it off right away to Lorenzo. Please get us started.
All right. So thank you, Joe. All right, so my name again, Lorenzo Valdez, and I'm the BIM coordinator for Turner Construction. Actually, I have to drive from Falado to the airport. We're doing an expansion of a Terminal 2 over there, and I'm handling all the BIM efforts over there. So real quick, I'm going to run you guys through what Turner is doing to help construction and how, I guess, using smart tools, right, in construction. Oh, sorry. Possibly. There you go. All right, so I'm going to talk a little bit about virtual reality. I'm just going to run real fast through this. I don't want to take too much of the time. So for us, virtual reality is a tool that helps us visualize what we want to build, right? So obviously we need models from the architects and engineers, right? We can put those together, and we can actually better visualize what the intention of the design is, right? These are a couple of samples of pictures that some of the colleagues sent me of the stuff that we're doing as a whole in Turner Construction. As you can see, we can take VR into the site before we do any civil work. We can show every stakeholder what's going on or what's going to happen on site, right? Next slide, I don't know if you can see real quick. We can, interior work, right? We can show some interior design. And right at the bottom is basically, I don't want to plug Unreal, but basically we use Unreal to make this world possible. Down at the bottom is some kind of programming language that uses Unreal, which is Blueprint, right? So it's basically visual programming. And it helps us, right, to make this possible, because none of us construction are, computer scientists. So we need something easier to make this possible, right? Without any C++ or C# or anything like that. Again, more samples of what we're capable to do with the virtual reality. Again, more information that allows the designers, the owners, to make better decisions of the end product. Okay, and right at the bottom, something that we can do with this application, you can make the world interactive, right? You can select a 4D sequence where you link the schedule with the construction of the project. You can actually visualize how the schedule is going to work. Again, a whole host of options that we can create with this application. Again, more samples. We can use this for safety training. I mean, this is huge for us. Obviously, safety is first, and we can literally, put this on subcontractors and have them train on safety, how to tie off, or the crane operators, you name it. I mean, the possibilities are endless with this. Very important, we need buy-in from the superintendents. They have a different way of thinking. I mean, they've been doing this for 30, 40 years, so they already have their own BIM or their own virtual world in their head. So for us to give them an Oculus or something like that, it's interesting to watch. But we're getting a lot of buy-in from them, which is great, right? And again, another sample of the language that Unreal uses. And then right at the bottom, some pictures from our colleagues utilizing virtual reality. And I think this case is Oculus, what we got going on there. So again, very quick, but I round it off to Steve.
So my name is Steve Oxtokalnis. I'm principal of a company called Matrix Technical Services. We're a consultancy to industry and a defense department on the application of fully immersive and optical see-through head-mounted displays in everything from architecture to entertainment to defense to medicine. I've been actually working with these technologies for almost a quarter century. You might ask, where was virtual reality 25 years ago? Let me show you. This is a picture from my lab in 1993 at Mississippi State University. And the way that this display here, so 2 high-resolution CRTs, one for each eye, stereoscopic wide-angle optics, or what they called leap optics, or large expanse extra perspective. We track position and orientation of the display in the joints of the boom arm there. It gives the exact same sensation as you would get with an Oculus Rift, HTC Vive, any of the other displays that are out. The key here, though, is what it took to drive this display. In the back, we needed one Silicon Graphics Onyx graphic supercomputer for each eye, compared to what we can do now, even down to just using a smartphone. The way that we were using this technology at Mississippi State, we used it within the architecture curriculum. So the students, they would learn traditional architectural design techniques. They would also start work with AutoCAD. Once a week, we would have them upload their CAD models to a central database. We would get them into a room similar to this with one person that would come up and they would use the boom display to fly through their design while everybody else passively viewed using simple stereo glasses, so that instead of giving everybody in the room their own virtual reality headset, we wanted to make sure that everybody's attention was focused in one direction as the students defended their design decisions. What the goal was to try and help the students develop a balance between what they mentally envisioned themselves designing and what they actually ended up communicating in the form of CAD models, construction documents, and so on. This was a project that was funded by the U.S. Department of Education, the National Science Foundation, the Fund for the Improvement of Post-Secondary Education, and the results of this, again, back in the 90s, was profound. What I would like to try and do with my participation on the panel here is to encourage everybody from the architects to the city planners, to any legislators, anything like that, to give serious consideration to the use of the modern technologies like this in the design of smart cities and the individual structures. Anything that involves visualization of complex geometry. I'm going to give you an example of one where use of the technologies, a few $1,000 investment, actually paid off huge. So this is the Paglia Ice Arena at Penn State University. Even before a single spade of dirt was turned into construction of the building, every aspect of the design was walked through, the BIM models, CAD models, everything like that. Now, during the construction, or during these design prototypings, a number of stakeholders were doing their fly-throughs, their walkthroughs, and so on, and you'll see up above the bleachers all the way around there's windows. While they were doing the walkthrough, and the walkthroughs were done using both head-mounted displays as well as what's called a cave, rear projection screens. You're given active stereo glasses to be able to, and gives the same type of very compelling sensation of being inside of the imagery. One of the stakeholders walked up to these windows and looked down, and he could not see the opposing team's bench area. He pointed this out to the designers, and the designers made a simple change to this, which it greatly expanded the view that they had of the opposing team's bench, and this is what the finished product looks like after the construction had been completed. So at this point, I'm just going to leave it at that, but there are making changes, as you know, after you start building is extraordinarily expensive, whereas a few $1,000 investment using the modern technologies upfront to be able to walk through the designs, even though you might think you have the skill set of being able to visualize this inside of your head, the complexity of these designs gets such that externalizing it and going and exploring the designs can save, whether or not it's a single structure or working on a large municipality, you can save extraordinary amounts of money just by applying these commercially available technologies now. So I'll leave it at that.
Thank you for having me. My name is Amy DiDonato, and I'm an interaction designer at Magic Leap, working on the user experience of our spatial operating system. And I'll explain a bit more about what that means. But first, a little bit about my background. I actually came to Magic Leap with a background in architecture and urban design. I have a master's of architecture from Yale University, as well as a master's of philosophy and architecture from the University of Cambridge, where my research focused was on the role of science and technology in London city planning. And between these experiences, I had the opportunity to spend a few years in practice, working on a number of large-scale mixed-use developments across both New York City and in London. And it was really through practice I became interested in the role of technology and the potential impact of technology on architectural production, and more specifically, how VR and AR could open new opportunities for architectural practice. So I'm excited to be here and to discuss that with you today. But to jump forward and kind of give you a bit of a background of what we're doing as a user experience design team, and to kind of expand upon what Rony mentioned earlier in regards to spatial computing, I'd like to give you a bit of a background on spatial computing from a user experience and an architectural perspective. So for those of you who aren't as familiar with our company, the Magic Leap One is a lightweight wearable computer that allows you to bring digital content out of screen space and into your physical environment. So this goes beyond simply overlaying digital content onto the physical world, but digital content respects the physical properties of the space. And so you could see that, in this case, the digital really becomes an extension of the physical. And in order to do this, it involves a combination of spatialized audio, haptics, physics-based rendering, and physics-based animation behaviors. And it's really this combination that allows us to interact with digital content in the same way that we would expect to interact with physical objects. So with spatial computing, there are countless possibilities across different industries. These are just some examples, from entertainment to retail to workplace productivity, new forms of social experiences, of course, architecture and 3D design. So we're really just at the beginning, and we're excited to see what our creators come up with. So where are we today? So today we have spatial computing at the scale of the interior, but we're moving towards spatial computing at the scale of the city. And I think, within the context of this conference, for cities, that means that physical materials, surfaces, building systems, public spaces, destinations will become the armature for a new kind of spatialized and contextual internet. And in order for us to have interactive 3D content that is tied to the physical world and to persist in the physical world, we actually have to create a 3D copy of our physical world. So this is an example of a process that we call spatial mapping. And it's really through spatial mapping that will enable location-based, site-specific digital experiences. So for example, in this hypothetical scenario, you could imagine visitors arrive at the Roman Forum. They're able to share an experience that allows them to visualize the history of this particular place. And I think that's one of the most profound aspects of spatial computing from an architectural perspective is the capacity to activate place in our cities in ways that has not been possible before. Also, in addition to bringing meaning to existing places, spatial computing will also allow us to visualize data and information that is latent within our cities. So this is, kind of what Rony was talking about earlier, the possibility of simulating and visualizing data in real time. And this also opens up the opportunity to simulate changes within our urban infrastructure before implementing them. And of course, in addition to its capabilities at the urban scale, spatial computing will also change the way we work, the way we conceptualize projects in architecture, the way we deliver projects to contractors, and the way that buildings are ultimately constructed. So I'm excited to dive into some of these topics this afternoon. Thank you.
Thank you. Hi, my name is Olivia Ramos, and I'm founder and CEO of Deep Blocks. We're a company coming out of Singularity University. Their purpose is to inspire startups to adopt exponential technologies and apply them to global grand challenges. And in our case, the global grand challenges was the future of cities and how we build and how we analyze what we're building. A little bit about my background, it looks kind of like this. I have a master's in architecture from Columbia University, my bachelor's in architecture from University of Florida, and a second master's in real estate development from University of Miami. So it's really nice to be back here and be invited to be here. After I graduated, I worked for brokers, for developers, for architects, for contractors, and I realized that everyone sort of takes ownership of this small piece of a project. And I felt like it wasn't fair for that project to be sort of split apart in that way, in the way we're doing it today. And I became really obsessed with combining these processes and these industries into one system. And that was possible through two programs, the Singularity program and a program with the Department of Defense, the DARPA Innovation House, which was all about bringing data into a new way, like analyzing data in a new way. So our software in Deep Blocks combines the logic from a lot of these disciplines into a single centralized engine, or it's actually a series of engines, but that allows a single person, whether it's an architect or a developer or a broker, to understand the entire spectrum, to be able to look at a project and analyze it from every point of view. A little bit of the technologies that we're using, I mentioned exponential technologies, which was a requirement at Singularity University. One is crowdsourcing. So the system begins to learn from the users and begins to bring that data into a centralized global system where we can eventually see what would be an optimal building in London versus in Boston and sort of cross-pollinate this information. So that's one big aspect. That's something that the current alpha that's out in the market is doing right now. And then we're using two sort of different strategies within the umbrella of AI. One being sort of more like smart search and smart constraints based algorithms where we take in pieces of the zoning code and we make sure that we optimize based on the law, or we take pieces of the market and market data and we make sure that we're building, so it generates a series of mutations based on the zoning rules, the market rules, the construction cost, and so we can get an optimized version of a project in a matter of minutes rather than a couple of weeks or a couple of months, taking a lot of efforts from a lot of different experts. Excuse me. And then there's machine learning, which is a black box. We're not actually doing any machine learning right now because we're really exploring with what we've built so far, what would be the best use of it. But where we're getting to and the different tests that we're doing is to be able to understand the different cycles in the market and the different risks in building certain products in that cycle. So in a way, sort of being able to flatten the cycles and know when to build and where and what would be the optimal product based on population growth, migration, GDP, what's going on in the market, and so on. So the idea is to take this logic, which right now works for a single building at a time, expand it to a block, and then expand it to a series of blocks. So in a way, we can analyze, eventually we can analyze an entire portion of a city at once. And then we can bring in really interesting subjects like transportation or infrastructure for sustainability, sea level rise, as a community, and allowed any person to look at their community differently and to have access to all these numbers. So this is sort of what we have right now in the market, which combines the financial logic with all the different market data and constraints, zoning, construction costs, et cetera, and the 3D model. And as you adjust the different assumptions, you can see how those assumptions, what the financial repercussions are. And as an architecture student, this was something that I always wonder, like, if I move this wall or if I move this design, like, what is that? What would that be? What would that do to the development deal? Essentially, for me, every architecture project is a real estate development project. So, I mean, I love the previous presentation. We are always sort of imagining how we're going to collaborate in designing the future of our cities, and we know that we're going to adopt these different interfaces for expressing our ideas, and we want to help and build a core or the content for these technologies to be able to move around pieces very easily and see what the repercussions are, how much it's going to cost, what is the optimal product for a specific population. So really grateful to be here, and that's it, Deep Blocks.
Hi, everyone. I am the founder and CEO of a company called Clarity Value, and what we do is take a first principles approach to what a city is. To us, a city is a geographical place. Second, principally, it is a collection of legal rules, a collection of processes, a collection of people, and the state of affairs right now is such that individuals who live in the city don't really have a connection to that city in terms of understanding what's even possible for them. If they want to engage in a project, that can be very simple, such as like rezoning a lot or subdividing a lot or getting a roof repaired, installing a fence. There's a complicated, sometimes way too complicated list of questions that they don't know how to navigate. And what we do with our company is make sure that citizens and business owners and anyone who has any kind of interest engaging with the city from this rules-based process can actually do that. And the way that this is borne out is in our platform, which I will speed through because I want to show you a demo actually. What our platform does is it takes all the rules of a city. We literally work with every department within the city, and we say, let's index all of this information, and then let's make it rich. Let's make it searchable. Let's make it such that someone can interact with it. And we're working with governments all around the country. So we're not just like localizing it in the coast. We're talking to everyone who has an interest in taking 21st century customer-centric responses and response rates I have a question, I want an answer, and actually getting them online with our software. This is the application engine. This is what, what I'm going to show you. But our first project, we got a lot of complaints about permits and how long it takes to get a permit, and the political process and how many gridlocks and bottlenecks are characterizing city politics and city development. So a lot of our technology today is applied toward making sure that again, on the first principles level, people can own that process themselves. They don't have to outsource it, or they don't have to rely on experts. They can literally just go in and engage with the rules of their city because it's public information. It's just, in the past, you needed experts to interpret that information. Our system does that now. But just as we've had a lot of success with land use, now cities are coming back to us and saying, well, can you help us with economic development? Can we make all the opportunities in this city searchable for other parties that might be interested, nationally or internationally? Can you help us with issues that are kind of cutting edge on the legal side, like cannabis licensing? A lot of cities understand that their states are legalizing cannabis use and distribution, but they themselves don't have the expertise to put kind of processes in place and run them without having to either hire more people or spend more money resourcing that outfit. Our system does that totally automatically. This is a couple of wireframes of what I'm going to show you, and some benefits of using a system like ours. Number one is, in addition to helping citizens, the people who live in a city and make up that city and do business in that city, is that we're also helping bureaucrats, which is not something that we expected. So we're being told that our tool helps them train new hires, people who are coming into government for the first time and don't know really the architecture of what's possible. They can now go into our system and say, well, if I get a phone call or if I get an email or someone comes in and says, well, how do I do this? You'd be surprised how many people in government don't know today, and they're supposed to be the ones that actually know. So having this central database, number one, equips them with the information, and number two, helps them get on the same page within departments, among departments, department heads at different levels of staff authority. And then something that is equally important to me, at least, is having systems like the one that I'm going to show you today be the norm in government really helps cities and city staff focus on problems that you actually have to think about, and not on mundane, kind of brain draining tasks, like, oh, I have to fill out this form now for the 100th time because we don't really have a process for repeating this kind of work and workflow. And then cities actually, we can go into the data through the panel, but cities are actually making a lot more money through our platform because now people are, instead of spending money on government relations advisors or permit runners, et cetera, individuals are actually doing all this directly. They're doing all this business directly in terms of, I want to build X, I want to do Y, I want to start this restaurant in this place. Now I can just go into the engine and do it, as opposed to having an expert even tell me whether I can do it in the first place and have to peddle influence, et cetera, which is an unfortunate reality. I've noticed that none of the panels have to have discussed politics, which in this space to me is ridiculous, because it's what I do 90%, in addition to the technical aspect of building this business, 90% of this is politics. It's getting people in the room from the government side and being like, how the hell have you not done something like this on yourself? And then unraveling that mystery, which is actually not a mystery. It's just, again, influence. So this is just a quote that I like to include as part of the deck. This kind of engines can really transform what's even possible. Because again, what you're doing is you're creating a relationship between every citizen and their government in a way that right now is just kind of not the norm. And for us, we just want to make that the norm. We want to increase the connection and increase the relationship. So let me just exit out of here. And I think I have can I zoom in? So this is a dashboard for one of our clients in California. And what they decided to use our engine for was to automate the entirety of their residential permits. So a user would log in, create an account. I have a couple of projects open already, but I'll just show you a new one very quickly. A user would go in and they would say, okay, I want to get a residential permit of some kind. What the city of Santa Clarita has done is they've organized a matrix of all the possibilities. So for instance, if you wanted to do an interior remodeling, you would see all the menu of choices. If you want to do a site improvement, you have all the options here within the jurisdiction. If you want to do something as complicated as again, do a lot split, change a property line, something that's technical and requires a lot of heavy lifting, something that might intimidate someone who's not an expert in these kind of domains, you can completely do without any kind of hand-holding with our guide. So I'll show you something simple for the sake of time. Let's say you want to build a swimming pool. I actually gave this demo to the city of Hialeah a couple of weeks ago, and they were very impressed. Our engine asks you for an address, and I have one here that's for demo purposes. Normally, there would be a pin on the lot. Right now, because it's the demo address, there's no pin. But a city can essentially configure all of the questions that dominate this process, involve outside agencies like environmental agencies. Located in low fire. We actually also have GIS clearances. So when you're building a project and you pick an address, there are at least layers that kind of flag possible issues that you might have with your project. And then whenever there's a kind of technical question, we have more detail that might walk someone through that question. And then we also have the contact agency listings, all the contact information, if you still don't understand what the question does. So let me just rush through this, yes and no. And this is the actual project right now. So what we do is, again, our system configures all of the requirements in chronological order. It gives you all of the zoning information that you need. It gives you all the forms that you need. It tells you who's responsible for it. It tells you, hey, here's where you have to go and actually fill out the form. Here's where you get the permit. And this is a simple workflow. When you're building a new house, for instance, and you have to get that house, and you have to assign an address, you want to take a lot and change it. What we found is that some cities take months, if not years, to do something that our system can literally do in seconds. And so my job is to go around the country, go to places like Miami-Dade County, though Miami-Dade County is interesting, and we can talk about that why. Go around the country and be like, hey, do you have something like this? Have you built something like this? Are you thinking about doing it? A lot of new governments, or governments who are adopting this innovation thinking, we're like, oh, we've thought about doing it, we just don't know how. And so I'll say, can we just do a deal? I'll give you a demo, et cetera. And that's it. So I can exit out of this, right? Okay, cool. And then I guess, leave it here, or? Okay.
Oh, yeah, how do I do? Yeah. And then to turn it back on, if people want to show the slides, just that button. Okay, wow, that was fantastic. I think all of you probably can tell that we have a very diverse set of panelists here, and the diverse in several ways, right? Diverse certainly in terms of the kinds of technologies that they're embracing and deploying in their work. Diverse in the kinds of the scales of their interests, and diverse also even in the way that they actually practice, right? And the moments that they intervene in design. So we have people who are trying to engage design of cities at the moment of planning, at the moment of permitting, at the moment of construction, and moments, of course, even of design and even education about design, right? So in a way, we have across the spectrum questions at different moments. And so I think that we need to ask them a couple questions to try to tie them together and get them to unify as a panel. I have a couple ideas about those, but again, I'd like the audience to ask things if they want to intervene. So I have to start with then, I think, a question about the different moments that you all are in the design process generally, right? Planning, design, permitting, et cetera. I think that also implies that all of you are sort of in the thick of it in design at sort of different moments and probably at different time scales. So I would like to ask a question about the kinds of time frames that you're engaging and the sort of the time frames that you think are relevant to the kinds of technologies that you're working at. So I know that, so for instance, Lorenzo is kind of in the weeds on a real project right now, right? Like the BIM that he's doing is being implemented at this very moment. And so his time frame that he's describing might be the current moment, but I think clearly for Magic Leap, they're thinking in a 20-year time frame or something like that to really fully realize some of the potentials of this. And what that speaks to is a kind of question of what kind of vision of the future city then you're engaged with, right? Whether it's a kind of incremental change to the city because your time frame is very, very small and contemporary, or massive changes to cities and infrastructure in the future. So I'm just going to go down the line and ask each of them to kind of basically tell me to answer the question, are there 5, 10, 20-year visions that you can speak to directly that are related to the technologies that you're deploying and interested in? Maybe Lorenzo, are you okay starting again, or should I mix it up?
No, that's good.
Okay.
That's good.
Great.
So for us in construction, I mean, for us, it's right now, to be honest.
Right.
I mean, as soon as the project is go, we gotta go, right? So we have to find ways to implement these new technologies to make us, better builders. Projects nowadays are super complex, so we have to find ways to make it interesting, not only for us, but for the client and for everybody that's gonna be involved during the construction process, right? For instance, writing RFIs, I mean, that's mundane stuff, but it is what it is, right? We got RFIs, submittals, things of that nature, right? We need to find ways that new technologies to make that happen. And the example that I gave, with the virtual reality going away from those administrative applications, it helps the team in the field visualize and create find constructability issues quicker, right? It's about making a quick decision, right? It's not taking a week to figure out how this beam is going to tie to this concrete beam, right? It's about making a quick decision right away, right? So we're using, again, virtual reality, we're using Revit, we're using Navisworks, we're using a whole host of applications to help us visualize, right? It's just about the visual, right? And I guess that's pretty much how I live. Okay.
So, quite obviously from what the images that I showed, the application of these technologies is here and now.
Right.
Whereas compared to 20 years ago, none of the software paths were available to go from AutoCAD into a simulation utility. Everything had to be written from scratch in order to do all of this. Whereas now, most of this can be purchased online. The tools can be purchased online. The area that we're finding our clients are really beginning to explore and are 2 to 3 years out before they solidly start to implement it isn't so much from the visual side, but from acoustic studies of the closed spaces that they're designing. There's software packages that are available now that will incorporate from the BIM model sound absorption coefficients and so on, so that you can very accurately simulate the acoustics of the insides of some of these buildings and concert halls and so on, large mezzanine areas. And this is the area that we're starting to explore now with a number of larger clients that takes it quite a ways beyond the visual portion. But on the visual side, in my opinion, there's really no excuse for not applying these technologies.
Sure.
The ones that are currently available, just so much can be there's so much benefit that can be gained from their application, not only in turning up design flaws, but selling concepts to the client, engaging the client more so that they can tell you, hey, can you move that window over a little bit more so I can get a better view of the lake? Or can you shift the orientation of the building so that we get more sunlight through the windows during the daytime? Most that aren't trained architects or engineers or don't have that ability to visualize inside of their heads they benefit significantly from this, and they're more involved themselves in the design process, whereas showing them the standard means of presenting your design decisions from 2D prints and everything that you tack to a wall to showing them 3D renderings and so on. In most instances, they can't grasp it, and so to be able to use these tools, allow the client to walk through, see what's going on, even if they're minuscule, so change this or that, just so that they feel they're part of the process and so on. There's significant amounts that can be gained for all of that. So.
I think one thing that I think all of our work has in common is, we're creating, in a sense, a digital bridge between design intent and the end constructed product. And I think, for spatial computing, there's sort of a near-term and more of a future-facing version of that. And in the short term, I think, of course, using spatial computing as a visualization tool. So to be able to actually, in 3D, visualize our projects, communicate design intent to our to stakeholders, to clients, and also collaborate with other architects and designers and engineers on a single model in real time across distance. That's something that is in the short term. And I think that when spatial computing could also leverage building information modeling, that's where we'll take it a step further, where we're able to bring spatial computing onto the job site, and there will actually be a one-to-one relationship between the building information modeling that we're able to produce in the architecture studio and the end result on the job site. So I think that's all very exciting, and that's a bit more of the here and now. But I think also, 10, 15, 20 years down the line, one question that I'm interested in is how architects and urban designers and landscape architects will be part of the creation of a spatial computing infrastructure. So will the architect's end product be the physical building itself, or will it also be the digital layers that are incorporated within it? So will we begin to deliver an end product that is more of a hybrid between physical and digital? So that's much more long-term, but I think something worth thinking about.
That's great.
So at Singularity, we learned that it's impossible for humans to predict exponential growth. And so we really love just like going as far as we can with where we want to be in the future, because it's impossible to really predict it. And so for the present moment, we imagine complete autonomy from every designing point of view. So autonomy from the developer to really explore the totality of a project. Without the need of a team, the autonomy of an architect to go straight to an investor because they understand the financial repercussions of their designs, and which creates a lot more competition, and therefore it improves the quality of the products that are being built and suggested. Because it's not just a single person making decisions anymore, anyone can make a decision on the projects. And we love that idea, and we love the idea of having instant optimization. Essentially, optimizing a building could be free if it's done by artificial intelligence. So we don't need to spend a lot of money and time on figuring out if this is the most optimal option. We can have the most optimal option as soon as we plug in the site. So that's the near term. In the long term, we imagine being able to optimize a city to help with governments that are suffering because of an influx or an increase in density, to be able to help governments who are designing and building new cities from scratch, and this is happening in Asia and in Latin America, because there are cities that are way too congested. To be able to instantly understand what would be the sustainable solution for a city, which is way too costly to analyze. Just to analyze today, in just the building today, it costs 25% more to analyze for sustainability, so it's usually not done. What if this was free? But we could do it at a scale of a city and grow cities that have no infrastructure and have solutions for that. And be able to input, for example, these are the local parameters, the local materials, and have the machine tell you what is the most safest, secure, sustainable structure that you can build for any community, for any cost, any level of poverty or any level of luxury as well. So that's sort of what we think about, and we're sort of like back and forth in the moonshot versus the next 6 months, and that's a really fun conversation we have on a daily basis.
Well, now that I know that I can't predict exponential growth, maybe I can comment on linear growth. What I've seen is that That's a question that every city will answer differently. There are cities in the United States that are very aggressive with implementing new technology to understand themselves better, understand their people better, and also just cut their costs. You know, you could just read the headlines today. There's governments are facing budget shortfalls all over because the reality is people don't like paying taxes. And if the government doesn't have money, then all of these technologies that we talk a lot about and think a lot about are really never going to enter the public sector at a rate that you would need to then think about, like, well, are we actually advancing in a blanketed style? Unfortunately, the reality today is that there are just pockets of advancements. I think there are some cities like Seattle, some cities, or actually counties like Los Angeles County, San Jose, as well, San Mateo, who are even hiring people to think and index about the possibilities of new technologies and how these technologies communicate with each other for the purposes of planning, specifically. And then there are other cities who are just not having that conversation at all. It just does not enter their purview of priorities given all the other things that they have to do, like think about transportation or public health or trying to get a corporation to move to their city so they can hire more people. With our technology, I would say for those cities that are being a little bit more aggressive, I think the reality is like in 3 to 4 years, the issues that we're solving won't be as painful. But for other cities, it could be 10 to 15 years. The other thing that I'll say is that in addition to these smaller problems, you know, like Olivia was saying, what does the next 6 months look like? What's interesting about the US, so the United States has 19,000 cities in the United States. And those cities don't really communicate with one another. They don't really trade information on best practices. They're competing with each other for opportunities. They're competing with each other for talent. They're competing with each other like who can have the most favorable tax policy and the most open-ended zoning or land rules so that other folks move there and abandon other cities. Until we change that dynamic, again, until we go to like the constitutional level of inquiry, like are these moves even allowable? We're not really going to see technology be as fluent as we would like for it to be in these conversations. These are more human-centric questions that have to be solved. This is a hard problem. You cannot move forward without having some kind of standard in that question before you can create a market where entrepreneurs like us can go in and say, okay, now we've sized the opportunity, now we know what we can do, we know how much money we can make in that end, and so therefore then calculate the problem and move forward. Hopefully, and maybe, you know, maybe not exponential growth, but maybe in 20 years, if people like you who are in the audience make more noise with your local representatives and also teach yourselves about what's possible. When you vote for folks who write the budgets, when you vote for folks who hire, expect this from them. Okay? You should know about what's out there. Because the reality is there are people who are getting elected right now. I mean, it's surprising how many meetings I've had with like heads of government who have no idea about what's going on. Yeah. And they're like, okay, well, you know, find this other person to talk to. And it's just like, it's a circle. You know, a deal that could get closed in 2 weeks takes sometimes 2 years. And for people who are in business, that's a stressor that, you know, we have to calculate around. So hopefully, you know, as we talk more and we equip ourselves and we learn more about what we can demand just as citizens from a technological perspective, the rate of increase will hit a point where we can actually say we're exponential now. We've hit a rocket ship. We're going to be seeing kind of like magic leaps in our homes.
Yeah, right. It occurs to me after all that whole series of questions that so many of your, maybe the other thread that binds all of the panelists right now is that there's this kind of impulse towards inclusivity in the process of design, actually, right? And so in some cases it's about project managers who wouldn't necessarily, you know, who have this inertia of their old ways, but technology as being a way to bring them, to improve their processes, to bring them in. In some of your cases, it's about actually the displacement of expertise with more publicly available information and processes, right? And so I think Olivia and Christian are both in sort of that kind of realm. Certainly questions of having clients being able to visualize the things you're designing for the sake of their being then included in the process. Maybe that is like the thing that binds all of you to some degree, and I think it begs the question then a little bit about again, returning to these questions that the panel is supposed to be addressing about design process, right? It begs the question about, who designers are, right? What designers will be doing in the future. And so I'd love to hear all of you maybe just speak to your own experience. Like, you all have different kinds of practice structures, right? It's from the entrepreneurial to being part of a research or a technology arm within a larger corporation. Some are more academically engaged. I think all of those, between your own experience and the fact that all of your technologies are about the kind of displacement of conventional designers for other kinds of people and the inclusion of other non-experts in the process, I'd love to hear you just, the analogy that I would run is that, of course, all this talk about like automation and digital fabrication, the world has already started the conversation about how conventional manufacturing has shifted, and therefore manufacturing labor as a thing has to be transformed like fundamentally. And I'm wondering what your vision of like design labor might be, right, based on your own experience and the kinds of how these technologies might disrupt that. I think that would be a really interesting thing. I know we don't have a ton of time, so maybe we'll try to do that quickly, but I'd love to hear your answers on that, actually.
So for us, would be, let's find the best superintendent. What does that mean? I don't know. Maybe give him a hi-hat and it has a Magic Leap goggle on it, right? And he's just walking around looking for issues. Or when we're doing a punch list, right? Things like that. Safety issues. How do we address safety better with the subcontractors? Right? Well, we can use virtual reality. We can train them with virtual reality, right? Actually place them in the virtual world. They can test stuff around. Moving away from visual technology, how about this, again, submittal process, mundane stuff, right? Well, we thought about blockchain, right? As soon as the architect approves that submittal, everybody knows that submittal was approved, the vendor, everybody can get that order right away, right? Same thing with RFIs. It's about, keeping everybody connected. I know Kristen talks about that. Everybody in the panel is going to be talking about that as well, right? How do we keep that communications and to make, again, that process quicker. It's all about, getting that answer right away, right? So.
Yeah, I think under that rubric, then you would be sort of arguing for kind of incremental progress, right? Evolutionary. And I think some of you might be a little bit more revolutionary or disruptive in your spirit. So I'd like to hear like where people are on that.
I can follow up on that.
Great.
I take heart in the fact that we've been here before in some sense. So like we've colonized, we've set up cities. It wasn't an overnight process. Zoning laws obviously have some kind of wisdom to them, right? We don't want an outhouse to be next to a butcher shop, et cetera. There are certain hard physical, biological conditions about existence in an urban setting that we want to avoid. And we at least have the knowledge to not do that. So like if you can imagine a list that says stupid things we should not repeat, okay, let's have that as the Constitution. But then from there, we can engage in compromises. So for instance, if we are going to take seriously this notion of entitlement, hey, you own this property as an individual, or you own this property as a corporate entity, then we can use technology to map out what that individual or what that entity can do, how quickly they should be able to do it, and then assign liability accordingly. And right now, the technology exists to do that, but there are people in the middle who have interests who don't want that to be the norm. So number one, other business owners, or people who, like for instance, have staked out political careers on preservation, right? People who are on historical preservation boards, people who are trying to maintain certain property values, and so don't want to zone away single-family houses because it's just their way of keeping the status quo, even when there's a crisis in front of them, right? So these issues are not new at all. We have dealt with them as a society since we decided to have a society. The question, I think, is who is going to decide? And I think that is not a question that we should delegate away. I think, again, until we have this catch-up between what the public in and of itself wants to do, then we're just going to go around in circle, like circling the drain, right, until the subject doesn't become that sexy anymore.
Yeah. Anyone else want to follow up on that, or should I open it up to other questions? Well, we're out of time, but I'm sure we could take one question if someone wants to proffer it for us. Yeah. Please.
As a student, you are the customer. The faculty, the administration of the school, the customer is always, well, maybe not in the school setting, but it's incumbent upon the students who are typically more on the cutting edge of new technologies than the faculty members are. Now, I'm speaking exclusively in an academic environment. Hammer your instructors respectfully. Bring to their attention the technologies that you're using that you don't see in use in the curriculum. Be constructive in how you present things to them. Think things through and pitch your ideas. One or two people presenting it to a faculty member or a series of members typically won't have an impact, but if you make a concerted effort and make your voice heard, try and give demonstrable demonstration of how use of this technology, learning more about this technology, applying it inside of the courses, as we've discussed about moving it into the pedagogy and so on. The more noise that you make as a student, the more responsive the faculty and administration are going to be. So this is precisely what we saw early on in the 1990s when this technology the first wave started to come through. Students were screaming for it. They were saying this could help us so much. And so they proactively started hammering the faculty and administration, saying, take a look, please consider this, and so on. And we saw that it went from those ideas actually into changing the very nature of how architecture is taught. And this is being adopted in architecture schools around the world now. So I'll just leave it at that. I can see a number of faculty members.
So that is a really good point, and super relevant for us because we were combining disciplines that normally people would just focus on one thing. We taught 5 semesters of graduate level design studios combining finance and design. And we realized that it was so much easier to teach an architect finance than it was to teach a developer design. and we did that, the software sort of reflects that. So we started with the first product as a super simple financial logic. And we are putting a lot of effort through blogs or through different posts to educate on what those simple terms are and how to use them. And know that the developers and the brokers and even the contractors sort of understand these terms a little bit, but we're very careful to bring in the architecture community in a way that was responsible and in a way that they can transition to more advanced levels of the software, which include waterfall calculations, loan calculations. So, but we're starting with something super simple as the back of envelope in order to be able to interact with the architecture community. But the education component is something that we take very seriously.
I can continue to be a little bit annoying. So open source technologies are gaining more in popularity, and there are a lot of providers that are teaching people the basics of even computer programming totally for free. So if you go, for instance, on Google and you type in the Mozilla Developers Network, they have a guide that you can walk through and like teach yourself the basics of programming. And it might not make you a senior full stack developer in like 3 or 4 years, but it at least teaches you the basics of how these technologies are put together, what's possible. And complexity really is just like a combination of simple things. It just seems like it's far off in terms of what you can understand because people lack the basics. So I think it's incumbent upon every individual to learn that, but there's also resources that are totally free out there for everyone to equip themselves on what's, how, the technology that runs our companies even.
I think, and Rony discussed this earlier, but as you know, Magic Leap has partnered with the university through Project Alexandria, and Dean El-Khoury has actually championed a advanced design studio focused on spatial computing. So I think this is an incredibly important aspect of introducing any new technology, is that the university really needs to be a test bed for these technologies, before they're able to be integrated into practice. And I think, with spatial computing in particular, there are some more short-term applications, thinking about AR and VR as a tool, as a design tool and as a communication tool, then there are long-term impacts on the design of the city and of the built environment that I think architectural students need to be introduced to right now. And that I think in how we have building standards and design standards and the physical environment, we'll need to begin thinking about design standards and regulations around our digital content in the future as well. So I think that these are the kinds of discussions that we should begin introducing into the classroom. And I'm excited to have that conversation as part of the Advanced Design Studio.
So real quick, for us, we actually have a Turner University. So this is whatever you need to know about construction. You literally, it's like a Google for us, right? We just type whatever we need, we go there, we figure it out. How to build a foundation, let me tell you, we can tell you how to do it. And luckily, as far as the virtual reality, Unreal is very accessible, open source to some degree, right? They have variable languages. Blueprint is a virtual language, so it's easy for us. We're not programmers again. So that's what we use, right? There's tons of sources out there. You got YouTube, Google, you name it. I mean, it's unbelievable right now. I mean, everybody here should be super excited about what's going to happen within 2, 3, 4, 5 years. I mean, it's amazing. So, yeah.
Okay, I think we're going to call it there. Thank you to all of the panelists. This was great.
This panel concludes our conference, and I'd like to thank you all for joining us for the great conversation today. I hope you enjoyed the presentations, the debates, the panel, the keynote speech. My mind is still racing, thinking about the consequences of what was presented in the keynote speech, but also in the 2 panels. It was great also to see this vision of the future juxtaposed with the ideas for immediate implementation, with impact for changing our everyday life in the first panel. And in the second panel, the shift, as Joel characterized it, from the product to the process, and here to see glimpses of the transformation of the profession. At least one of the panelists hinted to the disappearance of one particular kind of expertise in our field replaced by AI. So it's, these are, actually, I say at least one because actually there were other hints for radical transformations in the field. So thank you to all the participants, and I hope you all enjoyed their presentations as much as I did. And I would like to thank, of course, again, our sponsors, Bills & Sundberg, IBN, City of Coral Gables, and Zen City, who made this conference possible, and we really appreciate the support. Thanks also to the city of Coral Gables. We are very excited about this new partnership and look forward to the results of the competition. And finally, I must commend our team at the university, both at the School of Architecture and at the Center for Computational Science, for the meticulous planning, patience, and commitment to elevate this forum, this important smart cities dialogue every year. They remind me that smart cities are fueled by smart and dedicated citizens. And thank you very much. And now we have a reception, and please join us there to continue the conversation, and have a great weekend. Thank you.